Okay, so we're going to start with looking at the syllabus. So let me find the syllabus. I have way too many. Oh, here we go. Okay. Where am I getting at here? Okay, so start with the top. Welcome. Okay, so this is a syllabus, and my office hours are in the same Zoom room. So when you want to come and ask questions, you'll just come to this link that we're using and this Zoom meeting. So Monday, Tuesday, Wednesday, 2 to 3:30. I just sit here and wait for you guys. Thursday, 2 to 3. Okay, so this is what's in the syllabus. The syllabus was made for if you're meeting face-to-face. It doesn't work well to have a big break like this. We're going to take several smaller breaks. We will be using Lockdown browser for the exams and the quizzes. This is just like when you're taking your quiz, like you want to be someplace quiet, like find your quiet space. And I highly recommend the tutors. So the other tutor they were talking about, I know from Chem Club, and she's really super smart too. You have 4 excellent tutors for chemistry. That's very unusual to have so many chemistry tutors, but you guys really lucked out. Structural objectives, blah, blah, blah. That's, we have to put that in the syllabus because, okay, student learning outcomes, don't worry about that. That's also just verbiage we have to put in the syllabus because. Okay, so let's see. Okay, so this is the one that's directly takes you to the McGraw-Hill, and this is the one that's the $80. The deal that we got for you guys, and it includes the Connect. So it's this one. So this one has the ebook and it has the Connect, which is the access code for the online homework. And then this is your lab book. And we do have to use it because we will be writing formal lab reports. And this gives you the information about the procedure and the post-lab questions and all of that. This one is an electronic laboratory notebook. We will look at it today. This is separate. You pay this company the $20, but you can use it free for 2 weeks and then they will want their money. If you're an EOPS student, hopefully you already sent me your name, email address, and phone number. I will send that to the bookstore this Friday, and then you physically have to go there and ask them to check that you're on the list, and then they will take care of it. Okay, so do you have any questions about the required materials? Other than our student with COVID, you can unmute yourself and holler.
If we have a book like from last semester,
Yeah, it's the same book, but you do need the Connect. Okay, the Connect code. You have to check and see if your Connect code still works. I'm not sure how long they have made it to be active, but because the homework this semester is going to be on this online Connect code. It's really good. I took a look at it and thought about it seriously, and I thought, I really like this. It's really good. And it has the ebook too. So if you already have the textbook, you'd only have to buy the Connect. It says it's McGraw-Hill Connect. If you use this one, this is the one that's $80. It includes the ebook and the Connect. Did I answer your question or?
Yeah, that answers. And the lab archives is completely separate. It's a
yes, the lab archives is completely separate. That's your electronic laboratory notebook. No more carbon copy or carbonless copy, writing in those archaic pieces of paper and all that.
Well, guess that thing's useless now.
Well, you might need it for your other classes.
Okay.
No, the students last semester, once they got the hang of it, they liked the lab archives. And UCI uses it. There are so many other universities that use it. So why are we using paper and having you guys scan like 20 pages and then I have to
Individually.
read your messy handwriting? It's like, no. Anywho. Okay, other questions?
Is there a link for the lab archives, or do we just go
Oh,
to
I
the...
will show you that. Okay,
Okay.
that link is in the it's in the modules.
Okay, thank you.
It is when we go to look at the modules, I will show you.
Beautiful.
Yeah, it's in the Canvas course. Oh, I put it in here too. I put it multiple places. So to answer your question, here is the link.
Thank
So
you.
this big old long, see where it says Lab Archives self sign up. Yeah. So here's your link.
Thank you.
It is in the syllabus, and I believe, and it's in the module too. So everywhere, it's everywhere. Okay, so you will need some graph paper. And there's graph paper in the Marav, so you could rip it out unless you want to sell it again, then you can maybe Xerox it or make copies of it. Because your quiz 2, you're gonna have to make graphs by hand, old school. I'm just warning you right now, quiz 2, graphs by hand.
Okay.
Professor,
Yes?
I had a question about the lab notebook for the general chemistry or experience in general chemistry.
The Marav?
Yeah,
This one.
is it possible to, like, if we have a tablet, could we just have like the PDF version and do it through there?
I don't know if they sell the PDF version.
Cause on Amazon you can rent it for like $20.
Yeah, if you want to do that, that would work.
Okay, thank you.
You might have to make your own tables.
Oh, it comes with tables because I used it for Chem 11.
Guys?
Yeah, it has like the graph paper, so if you need it for the experiments, provide it
Nice.
still. So it's
Nice.
exactly like the regular.
Yes. As long as it's the 6th edition and it's the Marav. Okay, I am going to warn you that there's one experiment that the publishers took out, but we really like to use it. So you might want to have another student maybe make copies for you, just for the
Okay.
one experiment.
Okay.
And I'll warn you about that in advance. But yeah,
All right.
everything else, yeah, just go ahead and get this.
All right.
Yeah,
Thank you.
yeah, as long as you have it, that will work.
All right. It's the same one from Chem 11A, right?
Well, I don't know if we cut it in half for you. The Cypress College has a tendency to try to cut the lab manuals in half. The lab manual itself is pretty big.
Okay.
So okay. If you notice here what it says 4 Chem 111B. And see, this is customized. And then this is your ISBN. That's the second half of the manual. The manual itself is huge. So you want to make sure that it either, if you buy it on Amazon and it's the complete lab manual, that's fine.
Mm-hmm.
Or this one, see it says customize. This is the one at Cypress where it's the second half of the lab manual.
Okay.
But double check on Amazon that it's the entire lab manual.
Okay.
If it is, then you'll be fine.
All right. Thank you.
You're welcome. Okay, Canvas, how to use Canvas. I think you guys know how to use Canvas now, but just in case. Yeah, okay, blah, blah, blah. Okay, so yeah. And the way we're going to take the exams is you're going to phone in and aim your phones at your desk so I can see you. That's why it says video is required while proctoring exams during Zoom sessions. And then you would use your computer to take the exam or quiz. And we'll talk about that more also. Okay, blah, blah, blah. Oh yeah, we won't be doing an emergency drill, obviously. Okay, so here's your points. So exams, quizzes, and then the homework is going to total to 100. Your lab points end up being weird because I was trying to make them equitable to how much work you're doing, and it ended up being 222 points. So lab is typically between 200 points and 250 points. So this is a normal range. And since you're writing formal lab reports, you're getting a lot of points for those reports. But it just made the points kind of weird. And then the 3 exams, the final exam, 200 points. And so the points are kind of weird points, but it's still based on 90 to 100%, 80 to 89%. It's a typical scale. Oh, look, I put it in again. Whoever asked me, there it is, it's again. Okay, so I believe this is a little YouTube how to use it. And then we'll be talking.
Professor.
Oh, what question? I'm sorry, what?
On the Murov, the general experiments, the lab book.
Yes.
Amazon doesn't have the Cypress version. They have the
No, they
general
won't. That would
version.
only be in the bookstore.
Okay, so the regular one works then.
Yes. Okay, so if the one on Amazon is the entire complete, okay, this is making me kind of sick. Okay, if the one on, sorry, the one on Amazon is the entire Murav,
Yes.
then you're good.
Okay.
Except for that one experiment, it should have everything else. We don't know why they took that one experiment out because it's such a good experiment. But
Out
that
of
one, I'm
the-
sure someone else can help you with that. So yeah, as
Cool.
long as it's the complete Murav, then you're good.
Because if I order it from the bookstore, it's gonna take a while to get here. So
We don't need it yet.
okay.
We won't need it till the 3rd week.
All right, so I'll just order it from the bookstore then.
Okay. Okay, where were we? Okay,
Professor,
Yes.
this Murov, this one,
wait,
good, okay.
I closed the little box. Wait, who's?
This is
Yeah, that
me.
looks like it. Yeah, Maddie, that's it. Yeah, I think mine is in
Thank-
my, oh, I put it in my living room. Yeah, that's it. Okay, where was I? Let me find my place.
I forgot I had to have like 3 books near me at all times when I was taking.
Well, I had mine in the living room because I was making a PDF. So when I talk about the experiment, I can show it on my screen. Okay, and this is about the formal lab report. We won't worry about that just yet. Ah, here we go. Okay, so I'm so nice. I did not make you take a quiz or an exam this week. Okay, so we start with chapter 13, kinetics. We will be watching a safety video. We'll be talking about all of this. And then we'll talk about this lab activity and no quiz for this week. Okay, so this quiz is going to be on Tuesday, and it's on general chemistry. But to give you a fighting chance, I will tell you right now that there's 2 questions. They're free response. The first question is you have to do a balanced equation from a word equation. And it's a limiting reagent question. Oh, is it limiting reagent? Oh, it's not. I just had to figure out. Oh, I'm too nice. Okay, so it's a balanced equation, and I just give you the moles of one of the reagents and ask you how many grams of a product. But I'm looking at this balanced equation, and you need to know your nomenclature for sure. Oh, that's a good one. Okay, the second one is also a balanced equation. Oh, yeah, and then a bunch of dimensional analysis, a whole bunch of dimensional analysis that you have to show nice and neatly. So normally I don't really tell you what's on the quiz because it's usually like on a chapter, but I want to give you a fighting chance.
Professor, I have a question about the notes specifically. For
We'll
example,
get there. Can you hold on to your question?
sorry.
Okay.
Yeah,
Because everyone else is going, what is he talking about? Yeah, they're in the module. They might be under the instructional content.
okay, thank you.
I think they're in instructional content, and we'll talk about them too. Okay, I made little videos, which will make more sense later. But look, we have a quiz next week, and a quiz the week after, and a quiz the week after, and an exam the week after. Oh, you get a break. But your lab is going to be kind of, it looks worse than it is because I made little modules, little videos to help you with it. So to answer the other student's question, okay, see, week 3 is when you need the Marav. Weeks 1 and 2, we've got work for you to do. And then week 3, for sure, you will need the Marav. Okay. And as you can see, many weeks there's quizzes on Tuesday. There'll be lots of quizzes. But if you look at the quiz, it tells you what chapter it's on. So this quiz is on chapter 14. This exam is on chapter 14 and 15. Quiz on first part of chapter 16, and then the second part of chapter 16. So you want to use the syllabus as a reference so that you can find out what's going on, because it's all there. And then you get a final part 1 and a final part 2. Okay, so this kind of gives you a breakdown of the lab points. And they do, well, most of them are the same. But you want to get all these lab points, definitely. I mean, it's very typical for this class to just be intensive with the lab. Everyone has to go through it. So that's how it ends up being the 222 points. Academic honesty, okay. No one's gonna cheat. Yeah, I know you guys don't like reading the book, but at least read the words in bold. Okay, so I will answer the emails within 24 hours, Monday through Friday. Saturday and Sunday will be within 48 hours. Okay, so this gives you an idea of what kind of problems I like. These are in the back of each chapter, and these problems have the solutions so you can check your answers, but it kind of gives you a feel for how questions could be asked on the exam and quizzes. So that's kind of the benefit of doing these. You don't get points for them, but if you want to practice for the exam and the quiz, these are the problems you want to look at. Okay. So questions about the syllabus, which has all the information that you need. So you should be able to find it. Okay. Oh, Newton emailed me. Okay, let me find our class. Okay, so homepage, welcome. And I believe I double checked. Oh, here, oh look, I put it here too. It's everywhere. The sign up. Oh yeah, I like music, so I put some music videos on in case you guys are bored. Okay, so this is going to be for the whole semester. We will start at Monday at 12 a.m. So these modules will open up every Monday, 12 a.m. So if you want to get started on the module at 12:01, go for it. And then every week, all your assignments are due on the Sunday at the end of the week at 11:59. Now, keep in mind that it says here, I will answer the emails within 48 hours, Saturday and Sunday. So that means that if you try to email me on Sunday, I'm not telling you I'm going to answer you on Sunday. And my son actually last semester made me promise not to look at my emails on Sunday because I was getting so stressed. And so I don't want to break my promise to my son. So I need to take Sunday off. Okay, blah, blah, blah. And then my reminder, it's due on Sunday. Okay. And email me. Email is good. Okay. Okay, so then let's look at your module. Okay, so this is in your Canvas course, and this is your module. It's all very nicely organized. The first week looks kind of crazy because there's just a lot of little assignments where it says points. You want to get those points. You can do these at any time, but you want to get them done this week. Those points add up for sure. Okay, so I believe this is what Madi was asking about. Oh, here we go. Okay, so this is a little video to help you with the lab archives again, and we'll talk about it. You're going to want to probably scan your free response. So this is an app for your phone. Now, this is what Madi was talking about. So what we're going to do next, if you guys could go to your Canvas course and go to the instructional content week UNA. And if you could please go to where it says guided notes. This is a Word file. And this is a PDF. So if you could do that right now. And then either print them out if you could print them, or if you want to put them on your iPad, either one. If you could do those right now, we will be able to start with our lecture. So we will have these for every single chapter. So if you could do that right now.
How do you get to that?
Oh, okay. So you're going to want to go to your Canvas. So go to your Canvas course.
Okay.
Okay. And then go to modules.
Mm-hmm.
Okay. And then go to instructional content week UNA.
Okay.
And you click
Yeah, I
on
see
that.
it.
And then scroll down and it says guided notes. And then this is your Word document. And this is a PDF. So if you guys could do that right now, I will give you a few minutes.
Also, I tried ordering the textbook from that link. I guess it's actually a physical book. It's not just an ebook.
There's multiple ways to get the book. The bookstore is selling a physical book with the access code that they will mail you. And then if you go directly to McGraw-Hill, you can get it for the $80. That's the ebook and the access code.
Yeah, because it's the $80 one, but it says they're actually shipping me a physical book.
I checked the link yesterday. The one for 80,
Yeah,
as long as you're only spending $80.
Yeah, it's $80 plus the shipping, which is why it kind of threw me off.
Well, I asked our publisher's representative yesterday, and she said there is an option to just spend the $80 and get the ebook.
It didn't give me that option.
It should be on the McGraw-Hill website.
Yeah, that's where I'm on.
If I do this one. So you went to Connect?
Yeah, it says Cypress College Chemistry plus Connect Access.
No, that's different. There should be, we have got so many different links. There should be a link where you're just going directly to McGraw-Hill. If it says Cypress College, then that's the one that's involved with the bookstore, and they're going to give you a physical book and do the shipping.
No,
I believe it was on. I believe it was on my my syllabus.
I'm on the McGraw-Hill website from the syllabus link.
Uh-huh. So let me check. I know I found it yesterday.
It's the one that says Shop MH Education right under required materials number 2.
Is it this
Yeah,
one?
this one, yes.
Oopsie.
If we don't need it right away, then it's fine, but I don't want to have to wait for
This
it.
one?
Yes, that one.
Huh. I was promised that we had one that was just, oh, I see, you're right. It does say separate collection.
Mm-hmm. They ship you a physical copy. I don't see like an e-version of it.
Really?
Yep.
Hmm.
If you go to checkout and like finish everything, it says
Uh-huh.
like $15 shipping style book.
I see.
Yeah.
There might be a way for my textbook. I think there's like a QR code or something I might be able to send, so people could use that.
What? Wait. No, everyone has to do their own homework. That's not gonna
Well,
work.
it's
Okay,
well, it's
okay. So what
no,
I
it's
did.
just for the book.
Oh, okay, for the book. Well,
Yeah.
okay. So I
The
just,
problem is you need the code too, though.
yeah, you need the code. It looks like because it knows that I already have signed in.
Yeah, it's gonna let you log in.
Yeah, it's gonna let me log in.
Yeah.
That's not really what I wanted. Huh. Okay.
I mean, when's the homework start? Because if I order it now,
Oh
it's
no, the
probably gonna
homework
be like,
doesn't start till next week, and you can get a 2-week you can get a free trial.
okay,
I
so I'll
thought this
just
is the
order
one
that
that
then.
it does say.
I'm just worried that I won't get it in time.
Oh no, you can get a 2-week free trial.
Okay, so I'll just get it off of there, whatever.
Okay.
Yeah.
Yeah. So
Oh, it's free for
it
you.
does. Yeah. What? I don't can see it's. I don't know what's like.
Let me send that to my
It does say
printer.
this product will be shipped to you.
Yeah, it's a
Okay.
solid book. See, it says format book.
Yeah.
Yeah.
Well, maybe there's another URL. I'll have to look and find it. Cause
I think if you click the McGraw-Hill Connect, it'll send you to the website, and it for me it says fully digital experience with discounted
right.
loose leaf textbook.
Yeah, that's the one that should be the $80.
Yeah, that's what's on my screen.
Weird, mine says $80 too. It's that one link you had in the syllabus. But
So why don't you try going to the McGraw-Hill website and don't use the link I have, because apparently my link is for the the Cypress College one. Yeah, just try going to the McGraw-Hill website itself.
Or you can just click the McGraw-Hill Connect on the tab to your left.
Oh yeah,
this
and it'll
one?
come up. Okay.
Yeah.
Oh. Oh yeah, see, I'm the instructor. Okay, yeah, that doesn't work the same for me because I'm the instructor.
Oh yeah, I see it. Go to my section. Cool. Thanks.
No problem.
Yeah, it says $65 full digital experience.
Oh, go
with
to my
discounted
Connect
loose-
section. You mean this one?
Yeah, right there.
Oh.
And then it says you get a loose leaf textbook after registration. Okay.
Well, okay. Okay, so did everyone get their guided notes, which are their lecture notes? I'm hoping everyone did. So let me
And
find
Kinetics.
mine.
Go to my email.
Okay, don't look. Okay, there we go. Okay, so these are your lecture notes. We have this for every chapter. And so this is where you're going to want to holler if you have a question. And there is Zoom fatigue is real. So don't worry if your brain stops working. So we're going to start with chapter 13. And we're going to look at rates of reactions. So miles per hour, we would want to put the miles on top. So because we're doing dimensional analysis a lot, you're going to want to put it in this format where you want to put the miles on top and the hour on the bottom. And then the kilowatt per hour, you want to change this format. You're going to want to show that kilowatt on top. And then over, and you're going to want to put the time on the bottom. Okay, so it's to your benefit to show it this way because of all the dimensional analysis type problems that we'll be doing. So notice that the units on top are different in each case, but that we have a time unit on the bottom. So this is what you're going to see is some kind of unit on top. The time could be anywhere, seconds, minutes, hours, years on the bottom. But if you see this, you know this is a rate. And if I go, yeah, question?
Sorry, Professor. I have a question. This document, are you sure it's the same one as on the, if you go to the instructions panel, this one looks a bit different, or does this one just have all the answers filled out?
This one has all the answers filled out.
Okay.
This is what I did last summer to get ready for last fall is I typed in the answers because I didn't want to write on the screen because when I tried to write on the screen, even the school finally bought me a computer where I can use the stylus. My writing is really horrific. And so I did this so that it would be nice and neat for you guys. Does that answer your question, Maddie?
Yes, thank you.
Beautiful. Okay, so but please do it this way because we will be doing dimensional analysis questions all semester. Okay, so why do we care about rates? So rates are really important. So if you had reactions in your body that were too slow, it could be because of condition like hypothyroidism, and that's not good. If you had reactions in your body that were too fast, that could be because of hyperthyroidism. That's also not good. So this is just an example. There's lots more, but rates are really important. We're going to be doing a lot of graphing. So you're going to want to remember how to do graphs. You're going to want to have some kind of graphing program. So let's take a look at this graph. Yes, Moo Cow, I'm busy. Okay, so if we look at this graph, we're typically going to put time on the x-axis. So you're going to want to remember that for your future graphs, to put the time here on the x for these rates. Like when you're doing this chapter, or you're answering questions, or you're doing data analysis, always put the time on the x-axis. So in this case, you need to remember that these little brackets mean molarity. So this is a molarity of some kind of substance A. So here's your y, here's your x, and then this is our equation. And it's in the form of y equals mx plus B. So we're doing the same kind of graphing that you would normally do. You would get data in an experiment, and we're plotting the data very simply here. And so this would be a nice linear graph. So in this particular graph, the y-intercept is 0. So let's say you need to calculate a slope. So you would want, well, you guys, if you use Excel, it's just going to do it for you. Ooh, look at that. Okay, so there's my line. And then, oh, I see what oh, okay. Okay, so you're not really supposed to use the data to do the slope, and it looks like that's what I did. Really, you should pick points on the line here, but it looks like I got lazy. Okay, so there's my 10 molarity, there's my yeah, I shouldn't have done that. You're really supposed to just, this is such a beautiful line, but you're really supposed to pick points on the line that are not data points in case those specific data points were not good. Okay, but you really want to pick 2 points on the line and then go down and, oh, it looks like I didn't pick, okay, I got off a little bit. That was 26. That looks like that was 21. Okay, well, it's just off a little bit, but you get the idea. It's the same slopes you guys have been doing. But notice in this case, you have units. You need to put those units in your slope. So this is molarity on top, which is why we have the molarity on top. This is seconds on the bottom, which is why we would have the seconds on the bottom. So you're going to want to remember, in this case, your slope has units. Okay, so that's a typical graph. Let's look at another typical graph. Okay, so here's another graph. Okay, so what you are going to want to do is give me the equation for the line of this graph. So we'll take a few moments while you write the equation for the line for this graph. Oh, I'm not showing that. Yeah.
May I say it?
Yes, Maddie, you may say it. Yes, you may.
Let's see if I got rusty. ln of a ln of a is equal to m to the slope times the time minus 4, because that's the y-intercept.
Oh. You did better than me. I didn't put the B in. I left it more open. Yeah, I didn't write in. You're correct though. That is the y-intercept. So you would, if you wanted to be more explicit, you would put that in. I just put my y equals mx plus b. You
Yeah.
are correct. You are not rusty. So here's your y. Here's your m. Here's your x plus b. And he's right. This is, yeah, there's your b.
It feels weird to see -4 and then the times are in the thousands and hundreds. Feel like it wouldn't make that much of a difference.
Okay, so because we're doing,
ln.
yes, because we're doing that, we're doing logarithmic functions. Logarithmic functions are different.
In the technicality, if you just wanted the concentration of A, wouldn't it be A is equal to E to the power of M time -4?
Is it? I have to write it down. I can't do it in my head. Monty, you're asking me to think. It's too early for that. Yeah, we will be using natural log a lot. So there's like E to whatever. We will be doing that. We don't want to scare people. Okay, so here's another example of a typical graph that we will be doing. So same question, please write the equation for a line.
One over A is equal to M time plus 100.
Very good. Oh, I put it in this time. I put in the B this time. Yeah, this is, so we're not doing anything new. We're just doing graphs, y equals mx plus b. And we'll find out why later. Okay, so now we can start talking about rates of reactions. Okay, we're going to be using molarity, moles over liters. We need to remember the little brackets mean molarity, so this means molarity of A. Oh my goodness, sorry. Oh, fine. Okay, so what are some ways we can speed up the reaction? We can increase the concentration of the reactants. Or we can increase the temperature. Or we can increase the surface area of the reactants. So for example, if you have a rock and you have a mortar and pestle and you pound on the rock, or if you pound into a powder, that would be increasing the surface area. Or we can use a catalyst. So we're going to specifically be looking at reactions. And so our units are going to be molarity per second or molarity per second. And if you want to type your answers, this would be how you would type it. Or again, we said that the better way to show it would be put your moles on top. And then a line. And then put your time on the bottom. We very typically use the time in seconds because when we're doing reactions in the laboratory, we wouldn't want a reaction to take days. So this is the way, if you're doing this by hand, this is the way you want to do it. This is just easier when you're typing. Okay, so we have a reaction here. Decomposition of nitrogen dioxide. We get nitrogen monoxide and oxygen gas. And then this is saying to show the rate in the terms of oxygen production. And so this is how you would show it. So the delta for us means change. So that would mean change in the concentration of oxygen over the change in time. So that's what it means when we're showing this for us. For this chapter, this delta means change. We're also going to want to be aware of the time interval. If the time interval is very short, that's called an instantaneous rate. We'll do an example. Otherwise, it's called an average rate. So this would be an example on number 4 of an average rate between 5 and 10 seconds. So this would be data that you would be given, or you could find it by doing an experiment. So at 5 seconds, the concentration of the oxygen gas is 0.0050 molar. And at 10 seconds, the concentration of the oxygen gas is 0.0080 molar. So make sure you put the data that goes with each other. And so when you do the math, we end up getting a rate.
6 times 10 to the -4th moles per second.
Yeah. So this is a rate. You should recognize this as a rate. And it's the average rate between 5 and 10 seconds.
And instantaneous would be.
Oh, we'll do those. We'll do that. Yeah.
It'd be
Hold the phone on that.
okay.
I have to show that because if I say it, it doesn't make sense. But if I show you, it's easier if you can see it. Yeah, but see, we would decide this is an average rate because it's between 5 and 10 seconds. I'll have to show you this, the instantaneous rate. I will show you that. So technically, it's not short enough period to be instantaneous rate. It would be the rate of oxygen production between 5 seconds and 10 seconds. Okay, so this next question is asking about the rate of decomposition of nitrogen dioxide. So if we were just setting this up, we would say it's the change in the concentration of nitrogen dioxide over the change in time. So that's what it means. Change concentration, nitrogen dioxide. Over change in time. So again, in the laboratory, you would get data. Or if it was a problem, you'd be given data. So here's some data. So the data would tell you at 0 seconds, the concentration of nitrogen dioxide is 0.04 molar. At 5 seconds, the concentration of nitrogen dioxide is 0.031 molar. So the concentration of nitrogen dioxide is decreasing, which makes sense because you're losing it. And that's why you have this negative. You're losing reactant. So yeah, we're going in the forward direction, we're losing reactant. So you could be given different data. This data is between 5 and 10 seconds. And so the rate's changing. That's normal. So note, it is customary to work with positive rates. So how would you make the decomposition of nitrogen dioxide a positive rate? You could take the absolute value or just take the negative of the numerical value. Okay, so this is an example showing you how you could be given the data in a little table. And then the question is asking about the rate of production of oxygen gas over the first 5 seconds. Let's see. So we have 0 second, 0 molarity. So 0 second, 0 molarity. We have 5 seconds, 0.005 molarity, 5 seconds, 0.005 molarity. So this makes sense because this is a product. At 0 seconds, you have no product. But at 5 seconds, you have some product. And then you do the math and make sure you have your units.
0.001 moles per second, molarity per second.
Yeah, so yeah, you just say molarity per second. You guys can use this little to the -1 if you want, or you can put it on the bottom.
It's easier to do it on the bottom when you're working with other things and stoichiometric equations.
Yes, it is. Okay, so then this question is asking us to compare the rate of the nitrogen dioxide to the rate of production of oxygen gas over the first 5 seconds. And so this was our nitrogen dioxide. Now it's just asking us to compare the rate, so we're going to ignore the negative. Okay, so we put it in here. And then this was the oxygen over the first 5 seconds. And so we put that on the bottom. And look, we got a whole number. And then we're asked, does this make sense? Is this number random? Yes, it makes sense because we have a balanced equation. So take a look at the balanced equation. Okay, so we're going to lose 2 nitrogen dioxides every time we gain 1 oxygen gas. And that's why we got a whole number. Because of the stoichiometry. So yes, it makes sense. Oh, look, another graph. Ooh, look at this graph.
So the rate, did we, okay, did we do the nitrogen monoxide, or did we only do
Oh, I
nitrogen?
just ignored it.
Mm.
Yeah, I didn't want to do every single one because I just wanted you guys to get the idea.
According to the equation though, that would also be a 2 as well. The rate would be double that of the
Oh, okay. So if you're asking, if the question was asking about the nitrogen monoxide, you would get you would lose 2 nitrogen dioxides every
yes.
time you gained 2 nitrogen monoxides.
So the rate is
So-
1 to 1.
Right. So that would be I'm losing 2 when I'm gaining 2. And so their rates would be the rate of production of nitrogen monoxide compared to the rate of decomposition of nitrogen dioxide be 1. Or you could say the rate of decomposition of nitrogen dioxide compared to the rate of production of nitrogen monoxide would be 1.
Okay. Thank you.
You keep asking me to think, Madi. That's fine. Okay, so we have this graph, and this is going to happen sometimes if you look at the y-axis here. You see that to get numbers to make the graph, it's times 0.0001, and that's just to make it easier graph. So this is just what happened when the data was obtained. So given a graph like this, we're asked, what is the rate of production of oxygen over the first 600 seconds? Okay, so if we look at this question, actually, okay, let's not worry about the tangent line. Okay, so I did this. Yeah, I need to get rid of that. Okay, so don't worry, just ignore this part. Just ignore this. I don't know why I put that, because that's for something different. My brain was not awake when I typed that. I'll have to get rid of that. Okay, so what I did, because it said over the first 600 seconds, it says over. Okay, so there's a key word in here. The key word is over. Okay, so don't write down this part because my brain was not awake when I was typing that. Over. That means we need to look at the 600 seconds is right about here. Okay, so yeah, we're gonna have to guesstimate. 600 seconds is right about here.
Did you mean 6,000 seconds? Since the data ends at 6,000.
No. Because you can be asked anything between 0 and 6,000.
We could
You
just assume, we could assume 600 is that dot. It looks like it would be in that place.
Maybe.
It would make sense.
It might be.
If
It's
See,
above
what-
half and it's not that
Yeah.
close.
Well, when we're doing these graphs, we're each going to get slightly different numbers because it might be there. It might be real close to that.
It's probably a little further.
And mine, plus my line is crooked. But to answer the other question, you could be asked the graph ask the rate anywhere along this system, but you would have to stop at 6,000. But it would be fair game to be asked the rate. What we have to be careful of in this particular question is it says over. So I need some data here at 600, and again, I'm kind of just estimating. And then it looks like I went to 0 because oh, that one I know. so what you would want to do is you are asked this. You need to use this time. You, in theory, could use any time between this, but this is kind of curving. And so it's kind of hard to interpret. So that's why I started at 0. That I know for sure at 0 seconds, there's 0 molarity. And then 600 seconds, I kind of estimated what this was. This is a little bit more than, yeah. And so this would be over. So this is between, because it's between 0 and 600 seconds, it's going to be an average rate. So it is an estimate. And if there was a question like this and you have to do free response, we should all get the same exponent, the 10 to the minus 7. This number is going to change a little bit depending on how you interpret the graph. Okay, questions are, have we gotten to the Zoom fatigue?
Will all the graphs be like this, where they're very vague, no exact numbers? Because that's kind of.
Wait, there's numbers.
I mean, yeah, but you have to like guesstimate. Is that like 2.1 or 2?
Okay, so
We'll be
yeah,
given exact
yeah.
numbers.
Okay, so it depends on how much data you have, how many data points you have. And so this particular graph just has this data. And so if you had more data points, you'd have a better graph.
Like, I already have math anxiety, and this gives me more math
Oh, God. Okay, so really what you need to be concerned about is, did you get this 10 to the minus 7?
Yeah.
I would not expect everyone to have this at all. I would expect you to have 10 to the minus 7 and then not this. The math can really save you though, because what you're going to see is we're doing the same kind of math. And so if you do more problems, then you'll get better at it. So back in the day before you were born and I took this class, I remember just doing problem after problem after problem. So once you do a lot more problems, you'll feel better about it. Okay, so now this question's different, and the reasons it's different is because it says at. This one says over. That was an average. This says at. That's the one that's going to be the tangent. So let me show you how to do that. So we go back. Let's go back and look at the graph. Let me cover up the answer. Okay, so it says at. We will need to find the 4,000. So here's the 4,000. We estimate when it's hitting our curve. Whoop, okay. Excellent. And then we make a tangent line. So then when you make the tangent line, you want to pick 2 points on the tangent line. And it looks like this would be a good one to pick because, see, we're not estimating at all. We know that hits right at the 8 times 10 to the minus 0.0001. And then look at this one. That hits right at the 6. So we're not estimating those. We would, however, be estimating our time. So that's where the estimates would come in. So, oh, that's a little off. So we know that we will have really good values for our molarity, but we know that we're definitely going to have to estimate here. But because we're doing this at 4,000, we must do our tangent line and then get the slope. And then the slope of the tangent line will be the rate. So questions about doing that tangent line? So why don't you go ahead and try to do the calculation so you can practice before I show you, and then we'll see how close we are. I will give you some moments to do that. I will stretch. Does anyone need me to leave this up a little longer? Oh, I should see what you're saying in the chat room. I always forget to look. Wait, what is that little thingy with two eyeballs and a nose? What do you mean with a horrible graph? How dare you? Wait till you guys get wait till you guys get face to face in the lab room and you get your data. Oh my goodness.
It feels weird doing a tangent line without like a derivative.
Well, a lot of people have not had calculus, so
Yeah.
we have to just kind of not use the calculus so much. So yeah. It's close enough. Just don't tell your math teachers. They don't need to know. You guys are so funny. I still don't know. I guess that's just a what? Teach you should read the. Yeah, I don't read the chat. I gotta tell you guys, I'm really bad at reading the chat because I just get so focused on the lecture notes. I'm just really, so holler if you have a question. Last semester, I didn't use the chat at all. No one even asked for it, but anyway. So I'm going to tell you right now, I get sidetracked with the chat. So I was like, I forget if I don't even answer my phone. My daughter called me. She's like, oh, how do you answer your phone?
I got about 6.3 times 10 to the negative 8 molarity per second.
Ooh, that is pretty good. Okay, so you would expect to get the exponent. So the 10 to the minus 8, that would be expected that you would get that. But the other number, you would be given credit for if it was a little higher than 6, a little lower than 6. You definitely want to get the exponent right, though. And again, the key word is at. If it says at, then we know it's going to be the tangent line and it's instantaneous rate. And so I believe, oh, it also said, what is this rate called? It looks like I forgot to answer that part. Okay, so that's also part of the question. It asks what it's called. So it's the instantaneous rate. So make sure when you're answering the questions that you answer everything on the questions. You don't want to throw away those points.
Okay, so when you make that tangent line, you just pick two different points on that graph and then just do the slope of those points and then you
Yes,
get your answer?
yes.
Okay.
Yes. So this one is again asking at. So why don't you go ahead and try to do this for practice and let's see what you get. So it's asking at. Okay, so.
Professor, I have the question. Why exactly can we not do why can't we estimate the molarity of the at that time at seconds and then just divide it by the seconds to get that rate instantaneously? Why does that not exactly work and we have to use the tangent line? Is it just the tangent line is much more
Oh,
it's
you're
more
going to be
precise?
way off if you're estimating everything.
Okay.
You absolutely need to make a tangent line because otherwise your numbers are just going to be completely off.
Okay, thank you.
I mean, it's bad enough what we're doing. Okay, so there's my 5,000. So I would want to pick ones that I know I can read the molarities really well. So like there, that one would be good. Oh, this one would be good too. Or, okay, there's a couple of, let me give you a couple of choices because that would be a good option. This would be a good option. Ooh. There's actually 4 really good options here because my tangent line is so, okay, there's actually 4 options to try to do the slope because there's 4 times where our tangent line is going through a molarity. So pick 2 of those 4.
How are you making that tangent line exactly?
Oh, let me show you. It'll be easier if you can see while I'm doing it.
Uh-huh.
Let me just get rid of all of that. Okay. Okay, so the question said 5,000. So let me find my 5,000. Go straight up. Estimate when it's hitting the curve.
Okay.
That's not horrible. And then, see, in the face-to-face classroom, you guys would have had rulers. I would have asked you, I would have brought you rulers. There's my tangent line, right where it hits that.
Okay, got it.
Yeah. So you would use rulers. I don't know, in a Word document, if there's something you guys, oh yeah, there would, in a Word document, you could go to the, is it the insert? And then like there's little squiggly lines and then straight lines.
Yeah, that's what I'm looking for.
Yeah, yeah, it's in where it says insert. I want to say it's where it says insert.
What did you do right after you drew the straight line from 5,000 seconds?
Oh, so after I did the straight line from 5,000 to estimate where it hits the curve, then pretend like this is a ruler. If you were in a face-to-face and you had paper, you would just take the ruler and keep making adjustments.
Okay. And
Ah,
where do you
okay.
start? Do you start from like the origin or?
No, I just where did I start? No, I just like pretend like I'm holding a ruler. So let's say I'm holding a ruler like this. I'm like, oh. See, and oh, that was a bad one. That was like way too high. So it's curving up like this. So you want it to just hit right here.
Like shapes on their lines.
So I kind of have to look where I'm going to start because I want it to hit. That's not horrible. Yeah, every time you do the tangent line, you're going to be a little different because you're trying to just hit right there. And so you might have this side up a little high or a little too low, or this side up a little too high or a little too low.
So as long as we're close, it's okay.
Yes, yes, exactly. So really what you want to worry about is, are you getting the exponent? So are you getting close? Because again, we're estimating. Okay, so when I did this, this is what I got. So you should be 10 to the minus 8. And then maybe around 3. So maybe 2, 3, or 4. Okay, questions?
Yeah, I have a question, Professor. So let's say like on a test, we turn this in, right? And like you look at our tangent line and like it doesn't look too off, but when we do the calculations, it's pretty off. Like, cause my tangent line is like kind of straight, but I got like about 6.
Oh, that's fine. Did you get 10 to the minus 8?
Yeah, I got 10 to the
Oh, yeah,
minus
then
8
you're
though.
fine, you're fine.
Okay.
Yeah, I do not expect people to get this number.
Okay.
The
Just
10 to the
making sure.
minus 8, yes. Definitely you should get that. This number, yeah. Because see, this is about 3. You got 6. That's not horrible. Okay, but again, the key word here is this one was at. This one was at. But this one was over. So you really need to pay attention to details. If it's over, then that's the range. The
I
data
got
range.
about 5.3 times 10 to the minus 8.
That's fine.
Okay.
If it's at, there's your tangent line. If it's at, there's your tangent line. So you are going to have to very carefully read the questions.
I do remember that when it comes to Google Sheets, this gets a bit easier.
Okay, so we need to take a 10-minute break. Or actually, it's going to be, 10-minute break. Okay, let's take a break till 10:45. And please get up and stretch and walk around because we've been sitting for a while. So we're gonna take like a 10-minute break.
I had a question about the time. When I was on the what's it called? When I was applying for the class,
Yeah.
I remember the time said 9 a.m. to 11:05.
Okay, that doesn't work for Zoom. We can't sit here from 9 to 11:05. We can't.
No,
It doesn't
no,
work.
what I mean is specifically that doesn't include lab time, does it?
Okay, so the first week we will be doing the lab activity together. Like we'll be doing the lab
Okay.
activity together. So the first week we're going to be here from 9 to 2 and 9 to 2.
Oh, okay, to 2.
Because yeah, I have some activities for you that we have to do in groups and breakout rooms. The second week and thereafter, usually I can get done explaining the lab by 1 o'clock, and then that hour from 1 to 2, you're doing the lab. And then I stay in the Zoom room and you can come back and ask me questions. That's kind of
Yeah, because the thing is, when I was looking at the times, right, I was confused because I thought 9 to 11 doesn't sound like enough time for a lab, but it didn't say.
Yeah, okay, so we also, oh my goodness, the curriculum changed on us and we used to just throw the problem solving in with the lecture, And then we were told, no, the instructors get paid different rates when they're problem solving. So you have to show that specifically on the schedule as a problem solving. I mean, my problem solving is all integrated. So we don't have a specific problem solving time, but to meet the district requirements of how we're paid, we get paid less when we're doing problem solving with you guys. And that's why the schedule just got all weird. So just ignore it. We'll be here from 9 to 2, and we're going to take a few breaks so that we're not sitting for too long. So like right now, you guys should be stretching or walking around or going to play with your beta fish or doing something standing. Don't be sitting. So until 11:45. Does that answer your question, Madi? No, he's gone.
We're staying till 11:45.
No, we're taking a break until 10. I'm sorry, we're taking a break till 10:45.
Okay,
You
thank you.
guys are supposed to be walking around and stretching. Oh, that went by fast. Wasn't your guys' class in Chem 111A 5 hours?
Yeah, it was.
Okay.
Yeah, but we had like, or it was like spaced out, so it wasn't back to back.
What do you
Like
mean?
between class and the lab. There was like at least like an hour or so break.
An hour break between the lecture and the lab.
Yeah.
We don't even do that face to face.
Really? It felt, it
Yes.
was like about,
Okay, so technically it's supposed to be 9 to 11:05. This is if we were in a building. And then you have a break from 11:05 to 11:30, and your lab would be from 11:30 to 2. So technically, well, you know, it depends. Like, as long as you have that 5 hour, as long as you have 2.5 hours of lab and 1 hour, 2 hours and 5 minutes of lecture, that's what it's supposed to be. So an hour would be a long time. If we did that, we'd be out of here at 2:30.
The closest, yeah, the weirdest thing I've ever had for a lab schedule was the first time I came here. My lab was I had lab first and then I had lecture, which was really weird at first.
That's because we only technically have 2 rooms in the division in the building. There's
Yeah.
only 2 dedicated chemistry lecture rooms in the whole building. We were
Yeah.
always fighting with math about, no, that's really a chemistry room and math, and no, that's our room. It's like, well, why is there a lab bench in the room? It's because of the rooms. Yeah, you're supposed to have 2 hours and 5 minutes of lecture and 2.5 hours of lab. So I'm trying to give you about the same time of breaks, but two different breaks instead of one big 25-minute break. An hour is a long time to have a break. You usually do that when you are stuck with, you don't have a room, like a lecture room. Anywho, okay.
I don't
what? I'm sorry, what?
I don't remember having any break for any of my labs. Maybe in 11A, like 30 minutes, but I
Yeah,
don't
it depends on the rooms. That's how everything gets scheduled in the physical building.
oh, I took it last semester, so it was,
Right,
everything was
right.
online.
That's
So
what
I
I
don't know.
mean. There's no physical building, so I don't know why you would take an hour break.
I don't know if it's an hour, but it was pretty long.
Okay, so this is completely different. This is called relative rates. So you're going to need to be able to do balanced equations. So this equation is balanced for you. But just to give you an idea of how questions could be asked. So instead of giving you the balanced equation, a way that this question could be asked is it could say comparing rates in a balanced equation given the combustion of butane, which is C4H10. So what this means is that it would be fair game to not give you this balanced equation because in your previous chemistry classes, you're supposed to know what combustion means. So you're supposed to know that combustion means plus oxygen gas, and that the major reaction for the combustion of a hydrocarbon would be carbon dioxide, gas, and steam. And then you would have to balance it on your own. So it is definitely fair, it's definitely fair game to give you words and you have to translate that into a balanced equation. And we're going to need a balanced equation. Okay, so we said previously when we were looking at the data that we could consider that in this case you would lose 2 butanes and lose 13 oxygens every time you made 8 carbon dioxides and made 10 waters. So we're using the stoichiometry of the balanced equation. So now what we're going to do is we're going to divide each rate by the coefficient of the corresponding substance in the chemical equation, and then we're going to equate them. And let me give you time to write this down, and then we'll talk about it. And then also just to kind of let you guys know, because this class is not supposed to be taught via distance education. And so we are required to have synchronous lectures. But I'll talk about my YouTube channel and explain what I did to help you. So yeah, we're supposed to be meeting with you and having synchronous lectures. So, okay. So let's take a look at what is going on here. Okay, so we notice that the 2 is going to be put underneath. The 13 is going to be put underneath. The 8 underneath. The 10 underneath. And then you need to also recognize that these are your reactants. Reactants. Oops. And they're going to products, which I cannot spell. Okay, so if this is a reactant, we're losing it. That's where this comes from, the negative. If this is a reactant, we're losing it. So we also need to put in that negative ourselves. So then this is a product, we're gaining it. Product, we're gaining it. So what we have done now is equated the rate of decomposition of butane to the rate of the oxygen being used to the rate of producing the carbon dioxide to the rate of producing the water. So this is how you set it up. You do your balanced equation. You make sure if it's a reactant, you remember to put the negative in and put the negative in. And then the products, just leave them as positives because you're making them. So questions about setting up the rates.
Are the negative and the positives, are they always going to be a 1?
Yes. So what you're going to do on this top here is you can always put this as a 1 for here, and a 1 for here, and a 1 for here, and a 1. So yes.
Thank you.
Why does the 2 go below?
Okay. That's because if we put this in words, we would say we're losing 2 and losing 13 every time we're making 8 and making 10. So in order to get the rate of the loss equal to the rate of the gain, we need to use the coefficients.
Okay.
Because this now is a rate. We're trying to get the rates to equal each other.
Okay.
So what you also want to be aware of is this chapter is pretty much brand spanking new for you since it's so different than Chem 11A. You want to be able to set it up and then give your brain some time to understand.
Okay.
So for right now, set up with the coefficients. And then after you do a bunch of problems, then your brain, it should make more sense to your brain.
Okay.
It takes a while. It's like, this is not going to happen overnight.
Yeah.
Okay, so then what does this mean? And that's what we're talking about is you look at the balanced equations, and that's how you get the rates to equal each other. So also, you need to have the proper balanced equation. If your balanced equation is wrong, then when you do the setup to equal the rates, then that's going to be wrong too. Okay, so now we have a question. It's giving us the value of the decomposition of butane is 2.0 times 10 to the minus 3 moles per liter second. And then it's asking us for the formation, the value of the formation of steam. So we would want to do our setup first. The best way for me to do this, because I don't want to think too much, is I just go ahead and automatically set up everything. So that way I'm just kind of doing a pattern. My pattern is let me set up everything, and then let me focus on the butane, because the question's asking about butane, and the steam. So if I just go ahead and set up everything, it doesn't take that long. And then I can just take the ones I need. Okay, so let me give you time to copy that down, and then we'll talk about it. So it's just asking us about butane and steam. So here's our rate for the butane. Here's our rate for the steam. And then we want to simplify this. So I multiplied this side by 10. And multiplied this side by 10. Oopsie. And that's how I got this. So the reason that we do that is because now what you're left with is just the rate. So we have the 1 over delta concentration of steam over delta time. So that's the rate of the formation of steam. So we do a little math so that we simplify, so we just have the rate of formation of steam. And now we just need to solve for that.
Professor, shouldn't we shouldn't the -10 over 2 times, shouldn't that be divided out to -5 delta?
Isn't that the same thing?
It's the same, but doesn't it
Maddie,
like?
I don't want to confuse people. I'm just
Oh, okay.
Yes, yes, Maddie. I want people to see that because if I do too many steps and don't show you, it can be confusing. So yeah, we're talking the same language. Okay, so now the question did give me some information also. Okay, so the question gave me the rate. But I need to remember this is a reactant. So when I put it in here, I need to put in that negative myself. Because look at the way the word was given. It said value. So this part is the rate. So I take the rate that they gave me, being aware it is a reactant, so I gotta put that negative in. So I did this part, the rate. I had the -10 over the 2, which is the same as -5. And so then I have a minus, minus, a minus, which gives me a positive. And that makes sense because this is a product. It's going to have a positive rate. So everything worked out fine. Oh, I ignored the sig figs. My apologies in lecture. I don't really worry about sig figs. I worry about them in lab.
Wait, so why did
You
you
want me to
make
go?
that
I'm
negative
sorry, what was the question?
on
Okay.
the 2.10 to the -3 moles?
Mhm.
Because so the other one's negative, so you make that negative to make it positive because it's a value.
Okay, so when you say the word value, that's just the numerical value.
Okay.
But we need to remember this is a reactant.
Mm-hmm.
And you are losing reactants. So the reactants are all,
Oh, got it. So
yeah,
that's why it's
so
negative because it's turning
yes,
on the steam. Got
you're
it, okay.
losing it.
And you're gaining H2 out,
Yes.
H2O at a
Yes.
yeah, 0.01.
Yeah, we're gaining the steam. So then it does work out because the negative of a negative gives you a positive, and you would expect this to have a positive rate.
And if you were doing the opposite with a product, if you were trying to find the rate of a reactant with a product, then it should.
Oh, right. Okay, so let me show you. Let me erase this because it's getting a little messy. Okay, so let's say that we were starting with this and we were given this rate. And we were solving for this rate. Because we're making steam, we would leave that rate as a positive.
Okay.
But see, in our setup, There's your negative. So when we would multiply this side by 2 and this side by 2 to isolate just the rate, we would end up getting a negative. So it works out. And then again, the more you practice these, then the more it will make sense to your brain. And then after a while, all I can do is give you a different equation. So you do want to practice.
It gets to the point where you start second guessing other chemistry.
Yeah. No, you'll be fine. Okay, other questions about relative rates. So this is a relative rates problem. Okay, now we're going to look at rate laws. We're going to study the forward reaction. So this is asking us to write the decomposition of nitrogen dioxide gas. So that's your balanced equation. And remember to put your phases in. Okay, so now it's asking for a rate law for the decomposition specifically of nitrogen dioxide. So that's our reactant. Okay, so this would be what the rate law would look like. So the rate is equal to this little, this is lowercase k, it's called a rate constant. The concentration of NO2 to the power n. This could be any letter, I just called it n because I felt like it. And the n is the order of the reaction. So here's the common orders. Now keep in mind the orders can be positive, negative, an integer, or a fraction, but we're going to focus on the most common orders. So if the n is 0, that's 0 order. If the n is 1, that's first order. If the n is 2, that's second order. And again, we're going to focus on these, but keep in mind they're not the only orders. We could also write a rate law in terms of the products. So this would be a rate law for the products. So the rate is equal to some rate constant K, and O to the Y, O2 to the Z. Again, I just picked Y and Z because I felt like it. You can pick any letters. So how are the exponents determined? They are determined experimentally. And how can we do experiments to determine rate laws? We could measure the appearance of a product by its absorbance. So you guys didn't do any labs last semester, so I don't know about, well, we'll look at spectrophotometers. We're going to look at instruments anywho. Okay. Okay, so now we have another type of problem. It's called the initial rates method. So what we would do is we would compare rates from different experiments. And so now we have some data. So if we look at our data, we see we have 4 different experiments. And this is our initial concentration of peroxide, hydrogen peroxide. For experiment 1, initial concentration of iodide for experiment 1, initial concentration of hydrogen ion for experiment 1, and initial rate. And I didn't show the units for the rate, but remember the rates would be moles over seconds. So in this case, it's moles over seconds. So we have 4 different experiments and we have all this different data. So here's our reaction. So it's peroxide plus iodide plus hydrogen ion gives triiodide plus water.
Professor, moles, isn't it molarity per second?
Yes, molarity per second. What did I say? I don't know.
You said moles per
Oh,
second.
sorry, molarity per second. Okay, then the question is to determine the rate law and the rate constant. So let me show you what I did and then we'll talk about it. So let me give you some time to copy this down. So when I want to choose my rates, I look ahead. So I see this one, if I look at 2 and 1, this one's changing, but look at this, same and same. So that's why I chose to compare rate 2 to rate 1, because look what happens. That's gone. That's gone. So here's my rate 2. So I put that on the top with the units, molarity per second. Here's my rate 1. Put that on the bottom, my units molarities per second. And then I just have to do the math.
What if you don't have anything that matches like that?
You will.
Okay.
Otherwise, you can't do this problem.
So you'd have to have at least 2 that have the same kind of deal.
Yes.
On it.
In this case, yes, because we have 3 different ones. So what I did is I took this first column to be my first one.
Okay.
My second column to be my second one. And my third column to be my third one.
So we'll always have one that has the same kind of ions. Okay.
You have to. Yeah, otherwise you can't do this. What I have seen students do is do it upside down.
Okay.
So for example, they did rate 1 over rate 2. That just makes the math a little bit more challenging. But you have to have these 2 cancel because otherwise you've got too many unknowns. I did give a question one time where you had to put in the number here to solve for one of these other ones. People didn't like that, but it's like you could still do it.
Okay.
So you get 2 to the m equals 2. Well, m has to be 1 because 2 to the 1 equals 2. So we know our m now. We have an exponent. And also you want to set up this way so I can see what you're doing. So those of you who do math in your head, I can't give you credit if you just give me this. Because I cannot read minds. Okay, let's look at the next one. So again, before I even set this up, I kind of look at this like, okay, this one's the same as this one. This one's different than this one. And this one's the same as this one. So that would be a good option because then I could find this one. So this is gone. This is gone. And this is a coincidence that it's also 1. It just happened to be the same. Then we need to find the hydrogen ion. So let's look at that one.
Oh, okay. I got confused for a second because on the rate 3 it says 2.03, but it's mistyped. It should be 2.3.
Oh, on yours?
Yeah, on my no, I mean where it says rate 3 is equal to k times that is to all of those numbers is equal to 2.03, but on the actual
Oh,
table-
right here I did a typo.
yeah.
My bad, I'll fix it. Let me write that down. Good call. I didn't see that, Maddie. Okay, so
I was getting like 1.73.
yeah, that is a pure typo. I will oh, can I fix that now? Apparently I can fix it now while I'm zooming. Huh. I never know what I can do while I'm zooming. It's like, I don't know what we're, okay. Okay, this is the same idea. So this one's gone. This one's gone. We've got 2 to the p equals 1. So we need to remember from math that any number to the 0 equals 1. So now we have our last exponent. Okay, questions? Okay. Now we can write the rate law. Oops. Okay, so our rate equals our constant, lowercase k. The hydrogen peroxide is first order. The iodide is first order. The hydrogen ion is zero order. Or we can simplify it like this. Either way, you would get full credit. So we could also answer this saying the rate equals our rate constant. And then if you leave it like this, it's understood that that's first order. It's understood that the iodide is first order. And then since the hydrogen ion is to the zero order, that's 1. So you could just leave it out.
And if we did actually want to solve for k, we would just
Oh,
substitute.
we have to solve for k. Yeah, so you want to be careful because a lot of times the question will ask you to solve for k. So if it does, make sure you do that because that's part of the answer. So we could pick any one of the experiments, put the data into our rate law, and then solve for k.
So you're saying we can pick any of the data from those
Yes.
4 and then just
Yes.
insert it? Okay.
Yes.
And it doesn't matter which one we pick, it'll
No.
always be the same. Okay.
So as long as you use the molarity from that experiment and the initial rate from that experiment, you're going to get the rate constant.
Okay.
So let's take a look at the units. So in this case, it was molarity per second for the rate. The hydrogen peroxide was molarity. The iodide was molarity. So we are isolating.
Inverse seconds.
We're isolating the K. That's supposed to be an arrow. Oopsie. Well, that's like a fire now. Oh, geez. Sorry. My bad. Okay. Okay, so if we're isolating the K, then we need to divide this side by molarity to get rid of it. And oopsie, and also divide this side by molarity. Because we're not only isolating the K numerically, we're isolating the units. Okay, so divide both sides by molarity. Then we need to cancel those molarities and cancel those molarities. And we need to cancel those molarities. And that's how we get per second, per molarity. That's how we got these units. So in this particular case, the units for the rate constant are per second and per molarity. They're going to be different for different rate laws. Okay, questions on the units? Do you want me to do that again?
Could we write this, would you prefer it this way, or could we write it as in like 1 over
1 over is fine.
second?
1 over is fine. Mhm.
Okay.
I did it this way because I was typing these. So you can imagine typing this all up.
Oh
It-
yeah, you have
It,
to go
it
into
was
the
easier for me to
equations.
type it this way.
Yeah. I know there's an equations on Google Docs, like it's
Okay,
like,
you're not going to be able to use Google Docs during an exam.
no, I mean for formatting, like I'd never use that.
Oh, okay, fine. Okay, do you guys want me to do this again with the molarities? Because I know we've got the Zoom fatigue setting in, I'm sure. Do you have questions on the units? Are you still there?
We should write the K instead of 0.0115. Shouldn't we do it in scientific notation?
I would be so happy as long as you got the right answer, whether it's in scientific notation or not.
Okay.
Okay, let's go back. Let's look at your modules again. Okay, so this was the instructional content. Okay, we'll do that in a second. Okay, so what I did is over the summer, I made videos because there are a lot of students who end up working to help their families. And so, and Zoom fatigue is a real situation. So if you look in the module, this is what we covered. So you can watch it again. And the students last semester loved it. I had a student who worked at Starbucks like at 4 a.m. and would finish just before class. And she was so tired coming to class. And she said to me, I had to go watch these videos because during class, I really couldn't listen. So I made these without students. So you can watch them over and over again. I highly recommend it. So that they're embedded inside this module. And then also I have a YouTube channel. Let's see if I can find my YouTube channel. Like I got too much stuff on here. Oh, I can't. Okay, where is my stuff? Where's my YouTube channel? Oh, there we go. Okay, the whole semester is on my YouTube channel. Everything's on there. So you can see there's the Kinetics 2, 3. I don't know where the Kinetics 1 is. The entire semester is on my YouTube channel. It's Daru General Chemistry 2. So you can watch over and over again. You can take advantage. Oh, I made more. So there's just the whole semester on my YouTube channel. And that's to help you. But I did embed the ones for this week in here. Okay, this one is really good. I really like this presenter. I think he calls himself Organic Chemistry Tutor or something like that. So I vetted this for you because I don't want you guys to waste your time, but he's really good. He does problem after problem after problem. So it's a really good one to look at. Let me see, sorry. Whoa. Okay. I'm going back to the modules because I don't want to accidentally show you the answers to the practice quiz. Okay, this is just kind of an overview to give you an idea what we're doing this week and the objectives. And I put the notes in here twice apparently because I'm redundant. What's happening? Why is it not? Is it go to the next? Oh, what's going on here? Oh no, my computer's frozen. Oh, there you go. Okay. Back to modules. Okay, so you're going to want to do this practice quiz because we do have a real quiz coming up next week. And then this is your safety quiz for points. My computer, oh, there we go. Yeah, just the first week is just a lot because there's a lot of little projects. So there's a lot of points this first week and you want to get all of them. You want to do the student contract, the using Canvas. This is telling you how we're going to be taking the exams and the quizzes.
I have a quick question.
Yes. Mhm.
So for the most part, like the modules in like week 1, all of that would be due by the end of Sunday, right?
Yes. So every week, whatever's in the module is due Sunday at 11:59 p.m.
Okay.
So we're going to be consistent so that everyone knows this is going to be constant. So if you wait till Sunday to do everything, and I promised my son I would not check emails on Sunday because it was stressing me out, then, because I had a student do that last semester, and it was really stressing me out. Yeah, I'm not going to be checking my emails on Sunday. For sure on Monday I will check them. So there's a lot of little points to be gained here. These to me are almost like freebie points. The safety quiz, I believe we set up that you can take it 3 times. And all these little, like, you want those points for sure. Okay, this is your lab archives. Let's go ahead and discuss that because this is going to be, that's 10 points. Hey, 10 points is a lot, man. Look at all the points you could get all on your own. Okay, the lab archives is free for 2 weeks and then they will find you and want their money. So let's take a look at the assignment this week. Let's just focus on that. So this is your assignment this week. It's called Chemical Nomenclature. Now this is to help you because in the past, students forget their chemical nomenclature, especially if it's been a while since you took chemistry. It's gone. It's like learning a language. So if you don't remember it, it's gonna be gone. Okay, this is very helpful, this introduction. The introduction helps you with explaining. I don't know why my internet's so slow. I think it's because everyone in the world is now on their internet. Okay, so this is to help you learn the content. Yes, it's like slowing down. Well, okay, so you want to read this. This introduction is just all reading. So let me just go ahead and show you the pre-lab assignment since I seem to, oh, now I'm going back. Wow. Oh, what the? Seriously, that's annoying. I got kicked out. Okay, let's try this again. Okay, so this is the one you're doing. Okay, so again, this introduction is just for you to read. I'm not going to click on it because my internet seems to be weirding out. Okay, so this says you have a pre-lab assignment, purpose. So what you do is you go under and you hover on it. So when you hover on it, on that little pencil, you click on the little pencil, and then you can put your answer in. And 1 or 2 sentences specifically describe the, to relearn nomenclature. How am I going to, by practicing. I mean, that's fine. Okay, now I'm not going to save this because that would be giving you the answer, because I want you to have to do that. But what you would do then, you would save the page. Now, what's really nice about this electronic laboratory notebook is if you only have time to do part of it, it saves what you've done. So you could just do whatever you got to. Okay, so here's some questions. So same thing. Hover and find the pencil. And this says identify 5 metals and 5 nonmetals that were not discussed in the introduction. Ooh, I think I'll highlight that. Okay, what color do I think I'll highlight? A nice, pretty light. Okay, and then you would type in your answer. I have to go back and look at the introduction to see what metals. Let's just make up something because I'm sure sodium was discussed, so that's probably not even a good answer. I don't know. Oopsie. My bad. Okay, but you are going to have to read the introduction because it says not discussed. Why did you choose these elements? Some were in column 1, which I remember. So you really just want to make sure you answer it properly. And then you would hit the save to page. I'm going to delete this because I don't want to be doing your work for you. Okay, so again, you answer, blah, blah, blah. Okay, then you save to page. Now, if you're done with doing all your answers, make sure you're done, then you will have the option up here to submit. So this box is a submit box. Let's see if I can get to the procedure. Excellent. Okay, so procedure, we didn't use any chemicals. There's nothing for you to do there. So now you got more questions. It says record your answers in the results section. So what I did, just in case someone accidentally deleted or did something weird, I have the questions in 2 places. So here's the questions, but you're going to scroll down. And then here's the same questions. This is where you answer. Oh, look, I gave you one. I'm so nice. Okay, so again, you hover. And then, okay, who knows phosphate ion? Oh, it says bold. I gotta say, put the words in bold. Where's the bold? Okay, bold. Okay, what's phosphate ion? Phosphide ion, anybody? Phosphide ion?
P3 minus?
Thank you, -3. Oh, I'm supposed to be in bold. Why did it unbold me? Okay, so you see there's a lot of choices here. I'm going to ask you to put in the bold since I have to grade, what, 50 of these? And then you see you have your little nice superscript here. And this is yeah, so that's what we need for this. I'm going to go ahead and then you save the page. So again, this is to help you because it's really sad when I'm grading a problem and last semester someone got the barium hydroxide wrong, and then that just everything after that just kind of snowballed, and he ended up getting 7 out of 15 points, and there was nothing I could do because his subsequent equations were wrong, his answer was wrong, it was like his balanced equation was wrong, and the points just kind of started adding up. So this is to help you. This is for your benefit, because you really need to know your nomenclature. So again, if you just want to do this a little bit of time and then save it, you just keep working on it. And when you're finally done with the whole result, then you do the submit. So make sure you do the submit after you're done with everything and this section. One more section. So this one has a table, ooh, and lots of questions. Okay, so again, you hover, find the little pencil, click on it. And then you can type directly into this table. Make sure you do the classification. Someone didn't do it last semester and they just lost a lot of points. So you're filling out this table. You're answering these questions. And again, you save to the page and it says what you've done, and you can just save part of it being done. It says what you do, and then when you open it up again, it already has what you've done there. Wait till you're completely finished and then do the submit. So this is what we're working on this week, and that's all we're going to worry about right now. I did include this little introduction to lab archives in case someone wants to look at it. But for this week, this is all we need to worry about. So the lab archives is separate. It's the $20 the EOPS students will have to go to the bookstore, because the bookstore and the lab archives are working together to get you guys this. So I will send them that list Friday morning. Do you guys have questions about the lab archives?
So the lab archive is where we do all like the pre and post
Yes.
lab. Okay, so then the
Ooh, look at all the people. Okay, and please put your name in, because when I grade these, your name pops in there. So you want to please make sure you put your name in there. Because if your email address pops in there and I don't know why this person has two. Yeah, they're not gonna, no. You only need one. You only need one notebook. This looks like the same person. Okay, one notebook. So it looks like people are already populating this. But to answer your question, oh, it's still updating. Yeah, everything's going to go in here. So to answer your question, let me go ahead and show. I didn't want to overwhelm you and show you too much and your brain's going a little crazy, but to answer your question, let me show you a typical experiment. Okay, so this is this week. This is next week. So it's not the Marav yet. But then take a look at this one. This is your first Marav experiment. This experiment 27 is a 2-week experiment. It's a 2-week experiment when we're face to face. So I made it a 2-week experiment to be fair to you guys. So if you take a look at it and you click on directions in your report. So I'm trying to give you some help here to help you for your report. So here you go. You title, so you would make changes to it and put your title in. And this is what you're asking about. Pre-lab questions, yep. So you go underneath it, you hover, and yep, pre-lab questions from your lab manual Marav. You will have to do a procedure. When we're face to face, you guys had to do pre-lab procedures. You got to do pre-lab procedures here too. You can do them very briefly. Step by step is fine. but they have to at least have the procedure in there because you want to get all the points. If you do something and I can tell, oh yeah, they left a whole bunch out, you're going to start losing points. But to answer your question, yes, this is where everything's going to go, which is really nice because it's organized. The introduction, I'm asking for about 150 words, and notice it says the theory. You already did the procedure, that's done. This is the theory of it. And then we'll talk about this next week because I don't want to overwhelm your brains. But yeah, everything's there. Here's your results and discussion from Marav. These are your post-lab questions. And I tried to give you a lot of help here with the conclusion. So if you answer these questions well, you should be able to get all the points for the conclusion. Does that answer your question?
Yes, I also had one more question. If everything's on lab archives, then why do we have to still go and get the Marov lab?
Okay, so the procedure is not on lab archives. If I took the procedure from Marav and put it in here, that's a copyright infringement. I could get sued, and the district could get sued. And then there's the results and discussion. When you take a look at the Marav, there's lots of results and discussion. So again, if I had just cut and pasted in here, again, sue me, sue the district. And I don't know if the district would give me a lawyer because I took the distance education course and I do understand about copyright infringements. So I might be all on my own. But yeah, there's just way too much we're doing in the Marav. There would be a major copyright infringement if I just cut and pasted the whole thing in here.
So since the what's it called? So since the Marav, we have to buy it because it's because you don't want to be copyright infringement.
I don't want to be sued.
Okay.
It's
So
a major copyright infringement if I just put the Marav on here. And I know that. I took a course.
So
Oh yeah.
hypothetically, if there was a way, for example, a QR code on my Marav that I could maybe accidentally
I
do a
am
group
not
chat,
listening.
would
I
that
did
work?
not hear what you're asking. See, this is Marav, 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 Marav,
Okay.
Marav, Marav, Marav. That would be such a huge copyright infringement. Marav. Yeah. We have not yet found a way to get around using a lab manual that you guys have to buy because the labs are pretty extensive and there's certain ones we have to do. And anywho, so did that answer your question? I would love to get away from getting you guys to buy a lab manual, but we haven't figured out how to do that yet.
Yes, that answered it. Thank
Yeah,
you.
yeah. I'm sorry, I want to keep my house. I don't want to be sued. And it is a good manual. So maybe one day we can get away from it, but yep. And I really thought about that. What can I do? Like I couldn't find any kinetics experiments, anywho, that were sufficient. Okay, so what am I going back to here? Where's my course? Oh, here we go. Okay. So that's this. So what's going to happen is you notice this is an assignment and it's 10 points. So you submit it on the lab archives and then I go in there and I grade it and then I will manually put the points in here to get to your grades. So when you click on this, see, there's no place for you to submit it because it's being submitted in your lab archives. And that's where I go to grade it.
So the Canvas assignment is just to track our points.
Right, right. So because we're the only chemistry class using the lab archives. We're apparently the only people in the school. So the distance education is so overwhelmed with work that they were unable to link the lab archives into the speed grader. So it worked out pretty well though, because the lab archives has a time stamp. So I could see the people who submitted it Sunday at 11:57. But because it's due at 11:59, if you go past that, you could have late points, and you don't want to do that. Okay, so other questions about your module setup and what you have to do this week. Other questions? Yes, I am recording because a student contacted me last week. So yes, I am recording. Okay, other questions? Okay, this is freebie points for you guys. You just want to do this for free points. So this is just the icebreaker that you're doing, and it is graded. Last semester, I just gave everyone the points. This is just to get you on the discussion and posting, and just start a little discussion. I can tell you, ears going back on a cat is not good. Okay, do you have other questions about the, sorry, about the module itself and what you're doing? This is because there was some concern. Well, yeah, this is like how to use Canvas. I'm trying to get you guys to learn how to submit. It's just a file upload. Seems like this semester you're probably more in tune with all the technological activities here. Any other questions about the module, or are you feeling comfortable with it?
So just go through all of these and just complete them.
I'm sorry, what?
Just go through all of these and just complete them. Like
Yes.
Safety
Yes.
quiz.
Yeah, where it says points, you want those points. And this one you can take 3 times. This is just a little easy peasy. Some people didn't do that. Really, I would not throw away any points if I was a student. This is just a little like making sure we're communicating. This is because some of the math professors were concerned about other people coming and taking people's exams. And that has happened at universities, but hopefully it's not happening here.
Okay.
Yeah, so all these, this is just practice, but all these points, yeah, these are pretty much freebie points. If you can take this 3 times, like, yeah. So all these points keep adding up and they're going to help you. So yeah, just do them as soon as possible, get them over with, because I know you guys are taking other classes, you're also working. And you each have to turn this in, but you certainly could discuss it with each other. I mean, you can share screens and Zoom and all that, or however, whatever you do. Okay, other questions? Other questions? Any other questions? Anything? Are you just feeling overwhelmed, or are you just like... Okay, we're going to take a 10-minute break. And then we'll come back and do the lab. Or the lab activity, I should say. Okay, so take a 10-minute break. Please walk around, stretch and all that. A nice little 10-minute break. Oh, yeah, time. Yeah, but it's, I mean, it's now 11:56. It's on a 10-minute break. Hey, Muka. Muka. Cow. Look at my hands are wet. I'm gonna get cat hair all over me. What, Cow? What is it? What is it, Cow? No, you don't get any food right now. Like, how do you act like you're starving? Like, you never get fed. Oh.
Professor, I've got a question. Today's
Yes?
lab, is it mainly just going to be the safety instruction video?
I'm sorry, what?
Is there going to be more to the lab than the safety
Oh,
video?
okay. So yes. We're gonna do some reviewing of Gen Chem 1. We're gonna do some working on clicker questions in groups. I gotta show you this one, the common lab glassware. Yeah, we're gonna, the first week, we do the lab together. So when we're face to face, we would normally work on the worksheets in groups. And so that's kind of what we're doing, but doing it via PowerPoints.
Okay,
Yeah,
thank
the
you.
first week we're doing the lab together till 2 o'clock. And then usually the second week I can explain everything by about 1 o'clock. And then from 1 to 2, you could work on the lab and pop back in the Zoom room if you have questions. So that seemed to work really well. But yeah, class technically is from 9 to 2. So especially the first, yeah, so yeah. Yeah, we were told we have to meet with the students from 9 to 2. So, okay. So there's been a lot of talk from the universities about the fact that the students have been in a pandemic for a year now, and schools like UCI are talking about having a maybe 1 or 2 unit lab course just for the techniques. So keeping that in mind, we're going to try to help you with at least watching the techniques and the glassware. So this particular one is glassware.
Glassware has long been a core component of the chemistry laboratory. Glassware's long-standing popularity has remained high because it is relatively inert, highly durable, easily customizable, and inexpensive. Because of these desirable traits, glass has been used to create a wide assortment of apparatuses. Being unfamiliar with this equipment could lead to confusion, misuse, and disaster. Therefore, a solid understanding of glassware is necessary to ensure safety and success in the lab. This video will explore many of the common pieces of glassware found in the laboratory. Laboratory glassware is manufactured with different compositions, each possessing unique properties that are useful in different experimental conditions. Equipment made from consumer-grade or soda-lime glass is the least expensive and is adequate for many applications. However, rapid temperature changes can cause this glass to crack. Borosilicate glass, which exhibits little thermal expansion, is preferred in thermally stressful conditions. This glass is manufactured through the addition of small amounts of boron and is often used in bakeware, such as Pyrex. However, both borosilicate and standard glass contain impurities, resulting in reduced optical quality. Therefore, a glass composed of purely silicon and oxygen is utilized in situations that require the glass to be transparent to UV light. This is known as fused silica or fused quartz. Now that you understand the different types of glass used in the laboratory, let's look at common glassware as well as related paraphernalia. We begin our survey with glassware used for qualitative analysis. Any measurements or graduations on this equipment are approximate, and they are best used for procedures that do not require high levels of accuracy. First, the beaker, one of the most common pieces of glassware, is available in a range of sizes. Beakers are often used to hold, mix, and heat reagents. Most have a small lip for pouring liquids. Test tubes, which are relatively small cylindrical vessels, are also used to store, heat, and mix chemicals. Their design allows for multiple samples to be easily manipulated, stored, and observed at once. Watch glasses are used when a large surface area is needed for a small volume of liquid. This is common for crystallizing and evaporating procedures. Watch glasses can also be used as covers for beakers. The crystallization dish is similar to the watch glass, providing a large surface area for liquids. However, it is more commonly used as a container for bath processes. Lastly, the flask. Each type of flask is shaped for its purpose, but all are designed with wide bodies and narrow necks, allowing the contents to be mixed without spilling. They are also easily fitted with stoppers. The Heirloom Meyer flask is the most common. The flat bottom allows it to be directly heated and used in simple boiling and condensation procedures. Next, we will review glassware used for accurately measuring liquids. The graduated cylinder is used to measure semi-precise volumes and deliver to another container. The surface of most liquids forms a concave meniscus in narrow glassware. Volume should be read at the bottom for accuracy. While the graduated cylinder is versatile, volumetric glassware is used when a higher level of accuracy is required. Volumetric glassware can be an order of magnitude more precise than a graduated cylinder, Each piece is marked with either TD or TC. If the equipment is calibrated to transport the measured volume, it is marked TD for to deliver. Conversely, other pieces of volumetric glassware are only calibrated to be accurate while holding the measured volume and are marked TC for to contain. The volumetric flask is used to make and contain solutions of precise volumes. This is done by first dissolving the solute and then adding solvent to the graduation to dilute to the intended volume. Unlike the apparatuses that are accurate only to contain, the volumetric pipette is used to deliver a specific volume with a high degree of accuracy. A bulb is used to draw the liquid, never by mouth. The burette is used to deliver variable but precise volumes of liquid, controlled with the stopcock. It's often used in titration experiments. Next, our survey will cover glassware that has more specific procedural uses. First, the round bottom or boiling flask is designed to allow for even heating and stirring to drive chemical reactions. To prevent spills, it should never be filled to more than 50% of its total volume. While traditional funnels have a familiar shape, there can be variations depending on their intended use. For example, funnels used for gravity filtration are fitted with folded filter paper. Powder funnels have wider stems designed for dispensing solids and viscous liquids. The separatory funnel is used in liquid-liquid extractions to separate immiscible liquids of different densities. It has a specialized shape with a wide top for mixing and a narrow bottom leading to a stopcock for the separation. The Buchner Flask and funnel are used for vacuum filtration. The funnel is typically ceramic with pin-sized holes in its flat bottom. It is fitted into the flask with a rubber collar to provide an airtight seal. The flask resembles an Heirloom Meyer in shape, but has a barbed sidearm for the vacuum hose. In some chemical processes, laboratory glassware may need to be sealed, connected, or supported. Sealing glassware is typically done with a stopper. Rubber and neoprene are used in pieces with standard necks. They can be manufactured with holes to allow for the insertion of tubes, thermometers, or stirrers, while still providing an airtight seal. Glass stoppers are used to seal equipment with ground glass fittings. These provide a strong seal, but the possibility of glass-to-glass seizing necessitates the use of joint grease. Joint grease must also be used when connecting two pieces of glassware together. However, because these joints are not mechanically strong, plastic connector clips are used to prevent them from separating. When additional structural support is needed, glassware is often clamped in place. Clamps provide the support by connecting to a piece's neck on one end and a retort stand on the other. While some glassware should always be secured, clamping can also be used to ensure that components stay upright during a procedure. Now that we've surveyed the many pieces of glassware found in professional laboratories, we'll discuss some of their many uses. Observation of naturally occurring spontaneous reactions can be performed in the lab by replicating their original conditions. Glassware is vital to these investigations because of its inert and durable nature. In the Miller-Urey experiment, the environment of early Earth was simulated in a round-bottom flask to investigate the abiotic synthesis of organic compounds. A large manifold of interlocking glassware helped to provide the necessary atmospheric gases, which was then sparked, simulating lightning. The product was pipetted out of the flask to avoid contamination and stored for further investigation. When synthesizing organic molecules, it is often necessary to apply heat for long periods of time. In this example, a carbon-carbon cross-coupling reaction was performed using an apparatus made from 3 pieces of glassware. The apparatus, made from a round-bottomed flask, a reflux condenser, and an oil bubbler, allows for the solution to be boiled indefinitely, without losing volume or changing pressure. You've just watched Jove's introduction to common glass laboratory equipment and their uses. You should now be familiar with the glassware used for qualitative, measuring, and procedural applications. Thanks for watching.
So hopefully in the fall, when you take OChem, we'll be in the new building and you'll be able to use some of that glassware, although yours is on a micro scale and that was on a macro scale, but still. Okay, and then we're in the lab, so we gotta talk about lab safety.
Some of the best moments of my life have happened in labs. Also, some of the worst, like the time that I took a week to prepare a sample for NMR analysis, and then a classmate washed out the vials while I was sleeping for the first time in 3 days because he couldn't find anything else to use for his experiment. Interestingly, that resulted in my personal most significant laboratory injury. We all have one. I cut my hand while punching a paper towel dispenser in frustration. No one ever brought it up again. Today, we're going to talk about how to avoid injury in the lab and some good techniques for using laboratory equipment correctly. First two lessons already learned: never wash out a vial you aren't familiar with, and don't punch paper towel dispensers. Let's start with some very basic safety stuff. Your hair. If your hair is long, it shall always be up in the lab. If it is not, it will catch on fire. I've seen it happen. It can also knock stuff over and include your vision and droop into your flask. Same thing goes for anything that might hang off your body in the lab. Droopy clothing, especially sleeves, are a total disaster. Clothes should cover your body as much as possible. I like to go long sleeve even. Never, ever, 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 ever wear sandals in a lab. Long pants, closed-toed shoes, and socks. Clothing that covers your entire torso. Always. I'm sure you look hunky in your muscle shirts, and I have nothing against exposed midriffs in principle, but not in the lab. Of course, your eyes are your most vulnerable organ. Always wear eye protection, and no, just glasses do not count. And if you feel like your eyes are starting to tingle or hurt, even if you don't know how something might have gotten in there, use the eye wash, because it never hurts to be careful, and you know, we've all wondered what it feels like. I've actually never done this, so this will be a new experience for me. It does not feel particularly pleasant, but it's better than having your eyes burned out. Do not eat or drink in the lab. Despite our best efforts, stuff does sometimes get where we don't want it to be. And if it gets in your food or you accidentally pick up the wrong cup, that's just a really embarrassing story for your obituary. Also, I would generally suggest avoiding working alone in a lab, especially if you're working with any machinery or hazardous substances, but it will be up to you and your advisors to make that decision when the time comes. You may have seen this little symbol before here. It's the hazardous materials or Hazmat Diamond, and it's got some useful information in it. Each little box is rated 0 to 4, 0 being no big deal, and 4 being holy monkey, be careful. Blue is for health, the red is for flammability, and yellow is for chemical reactivity. A 4 in health means certain kinds of exposure will kill you. A 4 in fire is both very flammable and gaseous, so impossible to control outside of a closed container. And a 4 in reactivity means that it is capable of exploding at room temperature. The little area underneath is for any extra information, like if it's radioactive or reacts violently with water or something. If you ever need to know more about a chemical and what it might do to you or to the world, there's the good old MSDS, the Material Safety Data Sheet. Every chemical has one, and it'll tell you all the terrible things that it might do to you. If you ever need to find one really fast, you don't need to go to the cabinet anymore. You can just Google MSDS HCl or whatever chemical you think is in the process of killing your friend. There will be information on how best to treat the person who got exposed. Of course, you should have always read the MSDS before you even touch a chemical. Also, you should probably assume that every liquid in a lab that is not water is flammable. This baby here is a fume hood. It sucks all the air in there out so you don't have to breathe whatever's going on in there. It's also why it's impossible to keep chemistry labs at the proper temperature, because the AC units and heating units are constantly pumping in controlled air, and these are constantly sucking it out. So if you're doing some chemistry that might contain some noxious fumes, that goes on in here. And if you want it to work properly, first you got to turn it on. That's the vent. That's the blower. Now it is sucking air. Second thing you want to do is make sure the sash is at the right level. This has a little thing that tells you where the sash is supposed to go. If you go above that on this model, It'll buzz at you. If the sash is higher than that, it's not going to properly vent all the stuff to the outside, and some of it might get into your face, and that would be bad. As a side note here, if something happens to you in the lab and if you don't know whether it was serious or minor, you're not sure, just tell your instructor. I once inhaled a bit of nitric oxide, which, though initially extremely unpleasant, seems to subside after a while, but it can have longer-term effects. Headache, nausea, disorientation, dizziness, pulmonary edema, death. So I'm glad I fessed up so that I could get taken care of. Speaking of, if you want to know what something smells like, do not stick your face in it. Waft it toward your face. Also, never test something by tasting it, obviously, and never pipette by mouth. I hear people say that and like, who would? But then I just found out that Heiko, the chemistry consultant for Crash Course, has twice gotten HCl in his mouth from pipetting by mouth, which I will never forgive you for. That is what these things are for. You put that on the end there, and then you go on, you draw the liquid up with this thing. That's what that's for. Also, these days, most pipetting is done by these guys, which are way cooler anyway. Pipetting is one way to move a substance from one container to another, and it's a pretty good one. But if you want to pour, you can pour. But let me just give you a tip. Commit. We tend to get all nervous when pouring stuff in the chemistry lab and go all slow with it, but that's terrible. You won't overcome the surface tension and it'll dribble down the side of the container, so just commit. At the beginning and at the end, destroy that surface tension. Okay, back to safety. The most common lab injuries are cuts and punctures, and the most common source of those is cleaning up broken glass, which you should not do with your hands, but with a broom and a dustpan, and then deposit the results into a bin specifically for sharp stuff. But the worst thing, and it has happened so many times and it's so terrible, is forcing a glass rod or a thermometer or a piece of tubing through a stopper, and then it breaks, and then right into and through your hand, and you're in the hospital, and you've been paying for the rest of your life, probably. So when you're doing this, and it is sometimes necessary, you can use a bit of water or a lubricant or some kind of Vaseline to make it easier to go through, and then you hold it close and make sure your hand is not on the other side. So very close, and make it go through like that, not like this, because that's, no. When you're done with an experiment, do not just dump the results into the sink unless this has been explicitly approved by the person in charge of chemical safety. For some chemicals, like common acids or bases, dilution is the solution to pollution. When they get diluted, all that's left is common ions like chloride ions from HCl or sodium ions from sodium hydroxide, in addition to some protons or hydroxide ions that are neutralized by buffer ions that are present in your sewage system anyway. Bottom line is, they can be flushed with lots of water. For other chemicals, flushing is not a good idea. That probably won't hurt you, but it might hurt the environment. Do put the products into an appropriate waste container, but not just any waste container. Different solvents and reagents have to be disposed of differently. And if you dump some stuff into the wrong container, it could totally end up reacting with the other things that have been dumped in there. Not good. Rule of thumb, always know the right way to dispose of something before you even start to use it. This is an apron. It protects you and your clothes just a bit extra in case you're working with something hazardous like concentrated acids. Aprons are nice because they're easy to get off if you spill something on them. Well, if you're wearing pants, you might hesitate a bit too long before you ditch them. Which reminds me, if you spill more than just a bit of anything super bad on your pants, modesty goes out the window. Just take them off. Also, while you're taking them off, you might want to run over to this guy here. His job is to dump a gigantic amount of water on you really fast. Now, usually, you don't get to see these things in action unless there's an actual emergency, but to thank you for sticking with us through this somewhat disjointed lecture on safety in the lab, I'm going to take this off. That's a lot of water. Thank you for watching this episode of Crash Course Chemistry. If you were listening, you learned what to wear in the lab, how to dispose of chemicals, how to avoid the most common accidents in the laboratory, how to pour properly, what the Hazmat Diamond is, what an MSDS is, and how to use a fume hood. This episode was written by me. Our editor is Blake DiPastino. Our chemistry consultant is Dr. Heiko Langner, who's sitting right there laughing at me. This episode was filmed at the Environmental Biogeochemistry Lab at the University of Montana, so thank you to them. It was filmed, edited, and directed by Nicholas Jenkins. Our script supervisor was Dr. Heiko Langner. Our sound designer is Michael Aranda, and our graphics team is Thought Cafe.
Okay, so if you want to watch that again before you take the safety quiz, that's fine. But you do have the 3 chances when you're taking the safety quiz. Okay, so let's see if I can get, okay. So then this is your Connect, which will be your online homework. The students really did enjoy doing it last semester because the way that this is set up, you can do the problems multiple times. So what I did is I set up the homework so that you can look at the answer, or it shows you how to do the answer, and then you can go back and do a similar question. And I set that up so you can do that 5 times. So you should be able to get all the points. So the way this ended up is I had homework per chapter. And so the homework is next week. So it would be on the Kinetics chapter. So you can see that there's going to be homework due for week 2, 3, 4, and then that chapter took a couple of weeks, and then 6, 9, because that chapter 16 is huge and that took a couple of weeks. So these are the weeks that the homework is due. So you can see it's going to be for that week. And then because everything is due at Sunday, 11:59 p.m. So you're going to want to spend time on this, but just keep aware it's just these weeks. And the idea is to have you practice. So it's to help you, which hopefully it will. So that's your online homework. That's the Connect. Okay, so then we're going to do a review because, again, the nomenclature is so important for you to be successful in this course. So I call this the essence of what you need. So does anyone remember 3 types of radiation that you learned from Gen Chem 1?
Alpha, beta, gamma.
Alpha, beta, gamma. Yes, this is the Rutherford experiment. So yeah, you're gonna want to remember that. So alpha particles, gamma is radiation, part of the electromagnetic spectrum, beta are particles. Okay, so we will be using this in chapter 19. We do chapter 13 then chapter 19 because nuclear follows first order kinetics. So since we just learned about first order kinetics, we go ahead and jump into chapter 19. It just, to me, makes more sense. So you're going to want to remember about the atomic number on your periodic table. You guys might want to either have a periodic table that you've Xeroxed or find one online that's really good. But it's nice to just have one printed out. And then remember the mass number. And remember we do this, this is our typical way. If you have a number up here, that's your mass number. And then the number down here is your atomic number. So this is, you want to remember this is your typical format. So these are isotopes of hydrogen. So this is the one that we see that we use for acids and bases. This is deuterium and then tritium. But you want to just recall that this is your atomic number, so how many protons, and then this is your mass number. And then uranium's got, these are 2 isotopes of uranium. So this is just showing you the difference between the isotopes of hydrogen. And then this wants the protons, neutrons, electrons. So this gives you the protons and the electrons. And then this minus this gives you the, anybody? This minus this gives you?
The number of neutrons.
Is Maddie the only one? Am I only talking to Maddie? Is everyone else gone? Thank you, Maddie. This gives you. You guys want to remember how to do this because it's going to be in chapter 19. That's going to come up pretty fast. So again, this minus this gives you the neutrons. Now, if you have something like this, you're supposed to go to the periodic table. Let me get my periodic table right here. So you have to remember on your own to go to the periodic table and look at it. And then I should have known that. I should have had that memorized. You would have to, oops, you would get that from the periodic table. So you have to put that in yourself. And again, we will be doing that in chapter 19, which is coming up in a few weeks. You got to remember, this is a way, if you go like this, and then you do a dash, and then you do the number, you want to remember that it's the mass number. So when we're going to chapter 19, we expect you to remember all of this. That this is another way to show the mass number. And then if you had to draw it out, you put the mass number there, and you'd have to look on the periodic table, and yep, I just want to double check myself. And you would have to put that on yourself based on the periodic table. So you should be able to go from this to this. Okay, so, yep. Superscript is the mass number, subscript the atomic number. Blah, blah, blah. Okay, so we had 11 protons, 11 electrons, and we had 20 minus 11 ions, so our neutrons. And then the other sodium had 11 neutrons.
Is the PowerPoint in Canvas?
It is so that you can review, but
Okay.
this is not, there's like 100 slides per chapter. So I
Oh,
just
wow.
kind of cut it down to 50 because
Okay.
I call it the essence. So yeah, it is in the module.
Okay.
It's because I am going through kind of fast and we're going to do an activity.
Okay.
But yeah, it's to your benefit for chapter 19 to do a review, because I've seen students get the answers wrong because they forgot this.
Yeah. Okay.
Yeah, you really have to have your Gen Chem 1 down well, because we use so many concepts from Gen Chem 1. And I cannot even tell you how many times students have gotten like nomenclature wrong or this part wrong. It's like, we expect you to really know your Gen Chem 1. But yes, it's in the module.
Okay. Thank you.
You can go back because I know you guys have oodles of time. Yeah, but definitely now is the time to review, because you can see we have a quiz practically every week, and the quiz is going to be on new material starting after next week. So you're supposed to remember this, periods go across, groups go down.
Yeah. Okay.
Diatomic, so a little typo there, it should be a lowercase r. Some of these ones I couldn't fix the typos because when I click on them, there was a weird kind of box thingy. So diatomic, so we got hydrogen, nitrogen. So you have to remember all your diatomics. Have no fear of ice cold beer. You guys know that one, have no fear of ice cold beer? Do you know what I'm talking about, or are you thinking, what is she talking about? Am I only talking to myself here? The have no fear of ice cold beer?
Can you repeat that?
Yeah, let me type it. Okay, so I use have no fear of ice cold beer. Okay, so have no fear of ice cold beer. That's my mnemonic device for the diatomics. These are typically they're gases, but this iodine can be crystal. So this is my have no fear of ice cold beer for my diatomics. Because again, I have to remember that it's iodine crystal. And that iodine crystal will be diatomic. So then we got polyatomic, we've got more than 2 atoms. This is ammonia. Everyone needs to remember their ammonia. Hopefully you remember your ammonia. Okay, questions? Oops, I gotta erase. What is that? Okay, I gotta erase that. There's a line. I don't know what that was. Oh, ions. Oh, yeah, yeah. Column 1 plus 1. Was that column 7A minus 1? You can remember all your ions. You're supposed to remember that aluminum is plus 3. There's a little way on the periodic table when you look at it. Aluminum is plus 3, and then you go down and see zinc is a plus 2, and then you go down, you see silver is a plus 1. And then these are some polyatomics. You should know all of these: hydroxide, cyanide, ammonium, nitrate. So you need to know all the names, and you need to know the charges. So here you go. Just know everything on here. This is what I was talking about.
Can we just have references for this?
What do you mean?
Like have a reference chart handy, because that's a lot.
Oh, okay. So when you're taking, okay. So what I allow you to do during the quiz is have one piece of paper that you wrote on. Your periodic table is supposed to be just a regular periodic table, but you could have a piece of paper you wrote on.
And just write all my ions on there.
Yeah, I don't care what you write on it.
Okay, yeah, because that there's no way I can memorize.
Didn't you already do that in 111A?
Yeah, I kind of already went in out the air and the other, so.
Oh, I see. Okay. Well, at least you're being honest. Okay, so this is what I was talking about. There's a kind of a little pattern here. This is plus 3. This is plus 2. Always. See, that's the only one that's there. And this is plus 1. So there is a little pattern. And if we look at the common, there are other charges that could be here, but most common, -1, -2, -3. This is carbide, -4. These guys change, these guys change, these guys change. And then these are always +1, these are always +2. So these ones, there's a pattern. Okay, so knowing the formulas and yeah, the shapes, yeah. Ammonia. You need to memorize ammonia though. Memorize this one. That would be a good start. Okay, molecular, empirical. So yeah. Okay, what is supposed to be in there? See what I drew there? What is that that's just theoretically in there?
Hydrogen.
Oh, the hydrogen's here. Like this is a hydrogen and this is a hydrogen.
An electron pair.
An electron pair. I think maybe what you were thinking of is this. So for ammonia, you're correct. There would have been a hydrogen. Let me do the dotted. But if you notice here, instead of the hydrogen, there was a carbon. So this is also an ammonia compound. And we need to remember about the whole concept of the lone pair here. This is going to be important when we get to the acid-base chapter. So this would be the shape. This is coming towards you, away from you, and then there is a lone pair here. So you'd want to recognize this as that it does have a lone pair, but we just don't draw it. So ionic compounds. And then reactive, yeah, it's very reactive in this column. Okay, you are gonna have to do this, or we expect that you already know how to do this. So what we're saying is that, for example, you have your notes you can refer to. Or if you can maybe memorize it. But if I just said aluminum oxide, like all I did was I said, okay, I want you to give me the formula of. Okay, so this is all you got. Let's just say I didn't give you this part. I gave you the words, aluminum oxide. So you would want to know that oxide is -2 and aluminum is +3. So how would you get them to balance out? So a lot of times I will give you the word formula or word formula, and then you have to be able to go to the formula. So that is definitely fair game for you to be able to go from the words to the formula. And of course, the formula is going to be important for balancing equations and for in the future using some other equations. And then, for example, you would want to remember that carbonate is a -2. So yeah. A little messy there. So there's some of them we expect you to memorize. Yeah, so magnesium +2, nitride -3. And so you want to be able to do the formulas from that. Now, I don't recommend always doing that because when we get to the electrochem chapter, sometimes this is going to kind of mess you up. This is kind of the cheap way to do it, and it works out in this case. So if I gave you any of these names, you could just give me real fast the formulas. This is where it's going to change depending on the compound, and someone obviously was not paying attention here because this is what, chromium 3 sulfide. I don't know how the heck someone did not do their job. But you want to be able to do all of these. You want to be able to go from iron 3 chloride to the formula, and from the formula, I'm sorry, iron 2 chloride to the formula, and from the formula to, well, I usually give you this instead. I expect that you know how to go the other way. These ones, these are all for a game, although we don't see the silicide very often, but you're going to see these other ones more often. And see, there's patterns. If you can learn the patterns, then that helps. So we're supposed to name these. It looks like the copper is a +2, and that's a nitrate. So copper 2 nitrate. Looks like that's a hot potassium dihydrogen phosphate and ammonium chlorate. Yeah, so you should be able to just spit those names out because you know your nomenclature so well. Blah, blah, blah. Oh yeah, so we have to just know and refer to things. Okay, so, and this is, what I'm asking you is like, what is wrong here? Anyone? Is there anything wrong here? Anyone? What is wrong here? So that's the actual question. What is wrong here? Maddie, anyone besides Maddie? No offense, Maddie, but you've been like pulling this class through. Someone else needs to take a chance. The question is, what is wrong here?
I'll be honest, I zoned out.
Okay, Maddie's taking a break.
It's supposed to be.
Okay.
It's supposed to be NO3 minus, not NO.
Exactly. Now, I want you to look at this because I've seen students do this and like, you don't want to do this. If you do this, I have to take off a point. So for example, on your lab archives, on the nomenclature that you're doing, if you accidentally type this in this way on the nomenclature, I have to take off points and I don't want to do that. I would love everyone to get all the points on the lab archives chemical nomenclature, but please be aware of this because I had to take off points. It's my job. What about the H2PO? Like, whoa, what about that one? Again, Maddie's already done his job for the day. And then our, was that Stephen who just answered?
Yes.
Okay, so anyone besides Stephen and Maddie? What's wrong with letter B? Just go ahead and give it a shot. Tammy. Well, Tammy, were you going to say something?
You hear me?
Yeah.
Okay. The 4 is supposed to be the subscript as well in the phosphate?
Yes. Yes. So yeah, this is wrong. It's supposed to be H2PO4 subscript and then a -1. But that's not how I would read this, so I'd have to read it wrong. What about C? You guys are killing me here. Talking into the void. Anyone besides Maddie, Tammy, and Steven?
It would be the same with the other ones. It would be
yeah.
NH4 plus. So NH4 would be
Yes,
the
you
substrate.
guys better know ammonium ion. Oh my gosh, yeah, ammonium ion is NH4. 4 is a subscript. But see, that's not how I would read this. I'd have to take points off, and I don't want to do that. Okay, well, thank you for participating. Oh, okay. Okay, so again, I give you this. You just like spit out the answers because you know all of this. And remember, Mercury 1 is that weird one. That's like a pair. It's like a twin. Yes, you got to be careful on them. This is Mercury 1. You said, remember, that's just the way it's stable. So that's just it. And then because we want all of it, we need the brackets. And then same, it's in the same column. So it's a +1. Yeah, we want everything to balance out to 0. And again, we got to be able to do these formulas because when we get to the equilibrium chapter, we're going to need to know what this formula is in order to do the problem. So the formula absolutely must be correct. This is when you have the non-metal. So mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. There's also undeca is 11. And dodeca is 12. Okay, so these are non-metal. So was that silicon tetrachloride and tetraphosphorus decoxide? Yeah, tetraphosphorus decoxide. Ah, what was that? Carbon disulfide. So CS2, 2 silicon, and then 6 bromides. So 2 and then 6. These are like the best ones. Unfortunately for you, we don't see them that often in this class. Ooh, we have a whole chapter on acids and bases, an entire chapter. Look how I'm busy. Okay, so let's look at our system here of some simple acids. So notice this would be AQ, hydrofluoric acid. This would be AQ, hydrochloric acid. This would be AQ, hydrobromic, AQ, hydroiodic, AQ, hydrocyanic, AQ, hydrosulfuric. And so they're telling you that you add, so you add a hydrogen ion, and that's how you got the acid. And then in this case, we had to add a hydrogen ion and another hydrogen ion. And that's how we got the acid. So if you know the anions, you should be able to go to the acids. So this is what they look like. Oh, no, these are oxyacids. So notice there's O's in there. Okay, so nitric acid came from nitrate. Carbonic acid came from carbonate. Phosphoric acid came from phosphate. And so we balanced out the anions with the H's. So the oxy anions, the 8 becomes ick. The ite becomes S. Now we have a situation here where this is still acidic because it could give you a proton, and this is still acidic because it gave you a proton. Well, oh, son of a, that should say phosphate. Somebody, whoever edited this was really not paying attention. Okay, so dihydrogen phosphate, and notice we're changing the charge here, monohydrogen phosphate. I don't know why they didn't put the mono in. They got lazy, I guess. Ah, okay, here we have a system you're going to want to remember. So this is a -1, -1, -1, -1. So we only need a hydrogen to get to the acid. The perchlorate became perchloric acid. This is a pretty nasty acid. The chlorate became chloric acid. The chlorite became chlorous acid, and the hypochlorite became hypochlorous acid. So all these anions gain a hydrogen to make the acid, and these are all AQ. So it looks like phosphoric acid, and it looks like periodate. So yeah, you want to just be able to just, you know them. Yeah, so the hydroxides, but this is the one last semester the student didn't remember the barium hydroxide, and he ended up getting 7 out of 15 points because that was nothing I could do because his balance equation was wrong and his setup was wrong, and oh, yeah, that was awful. Oh, well, this would be next year when you're in OChem. We are going to see acidic acid. We do use acidic acid a lot. But when you get to OChem, then you're going to worry about this. Oh, methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, undecane, dodecane. But anyway, that's when you get to OChem. Okay. Okay, so go back to our modules. Okay, so if on your computer, if you could please go to the modules to week 1. And then if you could go to this, it says discussion. Chemistry 111A review. And if you could please download the chapter 2. Did everyone follow that, or are you like paying attention? Am I only talking to Maudie and Tommy and Stephen? And you want me to do it again?
I'm here, but I'm not talking too much.
Okay. Okay, so if you would please download the clicker questions, I'm going to put you in breakout rooms. And if one person could please share their screen, and then you can discuss. And then when you're done, we'll get together and go over the answers. Okay, so let me put you in breakout rooms. Okay.
Download chapter 2, correct? I heard
Yes,
that right?
chapter 2. Let me put you in breakout rooms. Breakout rooms. Okay. Okay, I am creating breakout rooms. So if you please, oh, I have to open it, I guess, huh? Okay, so if you please join your breakout rooms and one person can share their screen, and then we can practice. Yay, everyone's joining their breakout rooms. Oh, I guess you guys are still there then, that's good. Oh, where's Bruce? Oh. Did you get kicked out? Okay, I'm going to put you in breakout room 5. Erica, are you gone or what's going on? Oh, okay.
You guys download the little PowerPoint she gave us.
If you want, I can screen share right now. I already have it here.
Yeah, that's fine. I have it open. But at least that way we stay on the same page.
Yeah.
How many questions? It's very short.
The nucleus of an atom is positively charged due to neutrons. No, that's false.
Wait, can someone screen share?
I will.
It does work better if you can screen share. One person can screen share.
There.
There you go. Yay. Okay, I'm gonna go back to the. Okay. Excellent.
Okay then.
So I just joined the breakout room, but it logged me off.
Okay, let me look at the breakout rooms and see if there's one. Okay, so let me find out what we're doing because room 1 is full already and room 2 looks like it's full. Okay, let me put you in room 4.
Sure, thank you.
You're welcome.
Charge is due to protons, not neutrons, because they're neutral.
Can someone share their screen? It works out better if one person's sharing their screen and then you guys can talk about it.
I'll share my screen.
Thank you, Jessica.
Hold up. There's one. I think it's this one. Hold on, I have to go to my system preferences to allow them. I don't know if someone can do it faster than me.
Yay! There you go. You can doodle on it too.
Okay, nice. Let me see. What the question was? We
Yes.
answer that one. And then we put false. Question 2. Most of the mass of an atom is contained in the nucleus.
The first one.
Yes. Question? I'm just an observer.
This one would be A, right? Because it's
Yeah.
metal, non-metal, noble gas.
Yep.
I think it was D for this one.
I don't remember any of these names.
I think it's D.
Except for C, but that I don't think so. I think it's D. Yeah, that makes sense.
Thompson.
Thompson.
I think it's D too.
It could be B.
I think it's B.
Proust
I can't even
sounds
remember.
familiar.
Yeah.
A has something to do with the
The electron.
yeah, electrons.
Right?
Yeah, but Proust, that name doesn't sound familiar, but Thompson does, but I'm not sure why. It's B or D.
We'll just.
Molecular, but I think it's, I don't know if it's binary or not.
Yeah, this is totally big time review for me.
No worries.
Extended solids.
I'm gonna say D.
As in dog?
Yeah.
D it is.
Yes. I agree.
Wait, no, sorry. Monatomic, right? Or diatomic?
Diatomic would be like those that have no fear of high school beer shit.
No.
This doesn't fall in that.
I think it was poly. I think it was B, right?
Well, Hg is what? Silver?
Yeah.
No, Mercury.
No, Mercury. Wait, no.
Oh, Mercury? Oh,
Yeah.
Okay.
This is Mercury 1.
Wait, which one is it? Oh, it's spaced out.
I think it's definitely not polyatomic because it's only one
It says
element.
that
It's a
polyatomic.
I think it's a monatomic
cation.
cation.
Yeah.
Yeah.
Cation? So A?
Yeah.
Yeah, because poly says it contains more than one atom of a different polyatomic ion. So you would have to have two different things in there. So
No.
yeah, it would be monatomic. And it's cation, yeah, because it's positive.
Okay then. Let's go to 17.
Chromium 2 trichromate.
What?
That's the answer.
Chromium 2 trichromate?
Yeah, because there's three there's 3 chromate molecules in that
Oh.
compound.
No, it should be chromium 3 dichrome. Should
Oh,
be
wait,
chromium 3.
my bad.
Oh, there's
Wait.
3 at the end, but then, oh yeah, chromium 2.
Yeah, my bad.
Yeah, yeah.
Wait, so B?
E.
B.
Oh, no, wait.
Oh.
Hold on.
Chromium 3 dichromate or chromium 2 trichromate?
I thought it would be chromium 2 trichromate because of the 3 chromate molecules.
Yeah, but you cross. It's gonna be chromium 3. It's a chromium 3 plus with a Cr2O72 minus. Do you see that?
Oh.
So then you cross the 3 and 2. So it should be E.
Yeah, it's E.
All right.
Yeah. Man, I need to relearn all this. Which of the following represents salt cobaltic thiocyanate? Thiocyanate? Tyson? Yeah.
I don't think I've ever come across
I don't
this
either,
compound.
yeah.
I haven't either.
Thiocyanate? Oh god.
I don't know.
I mean,
I'm gonna think thiocyanate would be like
I want to say
Something
it's
with-
B
something with
because
sulfur.
cobalt is 2 plus.
yeah. Let's go with D.
So that knocks out C and D. It could be E, but
Oh
I
no,
want to say it's B.
thiocyanate. I think that has like a charge of -1. So
Yeah, so I think. Do you know what the compound of thiocyanate is?
I believe it is SCN.
Yeah, it's FCN.
Okay, it should be
SCN,
B
yeah.
then.
And
Okay.
I went
Because
in
cobalt
online.
is 2 plus.
I went online.
Yeah,
I
it's
found
B.
yeah, it's B. Because I went online. I found that one B. Okay. Which of the following formulas does not represent a real compound?
C.
That could be a typo because
You can say it either way, like alkaline or alkali.
Oh, I thought it was just
the,
like
the reason why it would be transition metals is because
the column, right?
yeah, that's how I interpret the question. It's of a group of elements, and I'm assuming it's something about the group and not actually like.
Okay.
I mean, I could be totally wrong.
No, I think that's fair judgment. Yeah. Okay. Next question then. The species HG.
Are cations. That's ammonia and hydronium. So it would be
Which of the following formulas does not represent a real compound?
B.
D.
Magnesium O because O2 would be minus
Oh, yeah.
4 and magnesium is just plus 2. So yeah, that should be a minus.
That's manganese. Yeah.
Manganese. Oh yeah, magnesium.
Guys,
I always, oh my god, yeah. Manganese, yeah, I'm not sure about that then.
Yeah, because manganese, it could have been like manganese 4, and then this would be a compound.
I'm pretty sure copper is supposed to mainly
I know that thiocyanate is the SCN. I'm not sure of the charge.
COSCN subscript 2.
I was thinking that
So
one too.
Your charge, so VP.
Yeah. Cool.
so if you guys are done, you can join the main breakout room and we'll go over the answers. Most groups are pretty much finishing up.
Okay, thank you.
You're welcome.
Yeah.
How are you guys doing on the first day here?
It's good, but pretty long.
I'm sorry, what?
It's going good, but it's pretty long.
Well, the first week, because even, I mean, okay, so think of it this way. When we were in the building, the class is from 9 to 2 with a 25-minute break. So the first week, we do review. I know professors that have, I have so many worksheets, like paper worksheets. We're there till 2 the whole day. The second week, it kind of works out better that once I tell you guys how to do the labs, I can kind of let you loose to do them on your own time. So still it's like 9 to 1. But technically the class is from 9 to 2. And this first week, we got to go over this nomenclature. Because again, students lose so many points because they don't know their nomenclature. And they just pretty much are just throwing away those points, because if you do this setup correctly, but your nomenclature is wrong, but then say, for example, we're doing a relative rates problem and your balanced equation is wrong, well, then you lose points on the balanced equation. You lose points because your setup for the relative rates is wrong. You're going to get the wrong answer when you calculate for the relative rates. So you could have done everything correctly as far as how to set up relative rates. like you use the coefficient to make them equal, you use the minus when it was a reactant, but you had your nomenclature wrong, so it's like half the problem's wrong. So it's time well spent. When we get to the solubility with all the ionic compounds, those really, just so much of this depends on your nomenclature. So yeah, we must do it. So, and the other concern is, I want this class to transfer. So let's say in the future, and I have had this happen, a school contacts me and wants to see my syllabus. I want them to see everything on there, that yeah, we're remote, but that you wrote lab reports, that you did these experiments, so the class transfers. Because that would be horrible to have to repeat the class when you transfer to UC or anyway. Yeah, this class is the textbook part, the exams and the quizzes, they're the same level as they were before. It's just the lab part got a little weird. No, anyway. So yeah, the first week is kind of rough because it's long, but then after that, it's not as bad. Oh, it looks like people are, I think room 5 is still working. Give them a few moments. Let me go visit room. Oh, no, they're leaving. No, room 5 is left too. Okay.
So after the PowerPoint, what are we?
We have to go over the answers. We must go over the answers because who knows what you guys have been saying to each other. Okay, so let me share my screen. Okay, here we go. Okay, so chapter 2. Okay, what charge do neutrons have? Please.
Neutral.
They're neutral. Yeah, because they have the protons and the neutrons, and the electrons weigh a lot less than them. Yeah. It's on the periodic table, so yeah. Okay, you gotta look at the periodic table, you look at the mass number, you look at the atomic number, and then we get that 666 number. I don't know why they chose that one, but anyway. So chloride is a -1, so you get an extra electron, and then the protons are from the atomic number, and then the neutrons from the mass number. Okay, we got gold. What's the P?
Phosphorus.
Phosphorus, thank you. Oh, please don't say that on something different. Okay, and then we got the noble gas. Yeah, we just divide. Okay, we got dinitrogen monoxide. Got 2 kinds of atoms, that makes it binary. It's a molecular compound, it's non-metal, non-metal. Okay, so let's go over this. It just says copper. Which copper are we talking about? I cannot do subscripts on this. I haven't figured it out. Okay, so what are the common oxidation states for copper?
Professor, can you repeat that?
Yeah, what are the common oxidation states for copper?
1 and 2, or
Okay,
plus 1
yes.
plus.
So you have a copper 1. And a copper 2. So it just says copper chloride. How are we supposed to know which one it is? We don't. So you want to either say this is copper 1 chloride. This is copper 2 chloride. You guys have to specify. Because if you just do this, what's going to happen? You don't
You
want
would
to,
lose.
yeah, you don't want to lose points.
So would it be, when we specify, would it be CU Roman numeral 1?
Yes.
Okay. Or 2.
Yes. So this one, okay, so this one would be copper 1 chloride. Let me go ahead. I know you guys are getting your brains are getting full, so let me go ahead and so you can see it. So we've got copper 1 chloride, and I'll do a little arrow thingy. Copper 2 chloride. Okay, so here's our copper 1 chloride. Here's our copper 2 chloride. This should be a subscript. But Zoom was made for businesses, wasn't made, I mean, he just sold it to educators cheaply because he figured he could make a little bit of money. Little did he know there was going to be a pandemic. But yeah, this should be a subscript. But you guys have to do this. Oh yeah, you should have had this memorized. This should be like this is language. This is your other language that you're speaking is chemistry. Yeah, we don't have to worry about this guy. I mean, chapter 2, these are really good questions. This is the only one that we're never going to see this guy. Not really, so. Okay, the keyword here is elementary. Because what is an alpha particle?
It's like it's basically just a helium atom.
Right. Whereas we consider these other ones elementary. Whereas alpha particle is composed of several components.
And a beta particle is just a positron.
Yeah, well, the beta particle, there's the beta minus, which is the high-speed electron, and the beta plus, which is the positron.
Yeah.
Okay, so I didn't want to put all 200 subatomic particles. And we're only going to worry about the electrons, the protons, and the neutrons. You got all these other, oh wait, on the positron, we'll see the positron. So yeah, this is like all other ones too. It's kind of cool, but anyway. Beyond the scope of our course. What the heck is that? What is the charge of the atom? The charge of the atom is on what? Who's got?
There's an electron cloud outside
Exactly,
of the
electron clouds, man. Okay, so they gave us the Z. So we got, this is where we have to remember, we did that review real fast. We have to remember we take the Z and that's gonna go on the bottom. Okay, then you look on your periodic table. Okay, so you start that way. You take that Z, you look at the periodic table, and that's how you found the RE thingy. Oh, they have almost all RE except for the Wolfram guy. And then this one you just put on top. So we'll be seeing this in chapter 19.
It's a fun time not knowing how the element is said and just coming up with a name for it because you can't be asked to look it up.
Well, this is true. Yes. Okay, group. What does the group mean? Group is going up and down. You have to be very careful that one word makes the difference. Okay, this one is because there's two of them. So that was your best answer. Okay, so I heard people talking about the crossy thingy. Yeah, the crossy thingy does work in this case because what's the chromate? Chromate's a -2, and I'm sorry, yeah, chromate, dichromate. And then what's the chromium? Okay, that's supposed to be an R. Oh my God. Okay, chromium's a +3. You guys just have to know that's dichromate. So it can't be that, it can't be that, it can't be that. These are all not possibilities. So it's either A or E. So you work out the charge on the chromium and the chromium's a +3. Okay, so thiocyanate is a weird old name from who knows when. The thio group is, thio is an old-fashioned name for sulfur. So it can't be this one because that's cyanide. So see, if you didn't know what thiocyanate was, but you knew what cyanide was, which was in our little presentation, then you could automatically eliminate those. And then you need to remember what the ich is. Ich is not a specific charge, it's the higher oxidation state. So if we look at our possibilities here. Okay, so that was a +3, and this one is a +2. So there's the charges on our cobalt. This means that out of our two options, we pick the higher oxidation state. So that's what the ich means in this case. Higher oxidation state, which would be our cobalt 3. And that would be this one. Did you follow that, or your brain's full?
That makes sense.
It's just that's the way it is. We're going to use the Roman numerals, so that will make it easier for you. Oh, please, people. I won't mention any names, but okay, what is sodium? Sodium is of what charge?
+1.
Exactly. Thank you, Maddie. What's carbonate?
I had to look it up. It was -2.
You had to look it up.
I forgot.
Well, see, if you don't use it, you forget it. So that's why we're doing this, because you're going to have to use it. if you're balancing an equation and this is what you give me for sodium carbonate, what's going to happen to your balanced equation? It's going to be wrong. And if your balanced equation is wrong, then what you do afterwards is going to be wrong too. Don't be giving me these points because of your nomenclature. Okay, so this one is, we'll do a process of elimination. So first of all, it's saying sulfate. Well, let me get rid of this. That's not even sulfate. Okay, this is sulfite, and this is sulfide. I'm going to get rid of those. Now at least I have a fighting chance. Okay, so let me look at this one. So what's my copper on this one? That looks like it's copper 1. And this one is copper 2. So this is the ick. So the ick means the higher oxidation state. So that's going to be that one.
What's the water part?
That's just there hanging out. That's a hydrate.
The
You can
name
keep
was
that
on.
off easily.
I kept forgetting that name. It was on the tip of
It's
my
a
tongue.
hydrate. Yeah. So this is going to have the most similar properties to cupric sulfate because it is cupric sulfate pentahydrate. So you just heat that water off and then you got the cupric sulfate.
Although, if we were to give you that answer, wouldn't we have to put cupric sulfate pentahydrate?
Yeah, so if you had a different question, let's say the question said to name this. You would name this, we're going to use the, oh my God. We're going to use the Roman numerals. We're not worried about the ick and the us and all that. So what is this? Copper 2, sulfate, penta. So if the question was to name it, then we're going to use the Roman numerals. That's Roman numerals are so much better and clear. But then whatever this is, penta, and then this is hydrate. So this would be the name of it. Okay, and that's the last one. Yeah. Okay. So I want to make sure that everyone is real comfortable with the, I Googled that just to be sure because yesterday's class thought I was wrong. Okay, real sure with, okay, oh, sorry, that's my channel. Yeah, like I said, everything's on here. I'm going to put this, today's on here too for the student. And then, oh my God, there's so much on there. Where's my lab archives? There's so much on there that's going to take you a while to find what you need, but it is on there. Okay, I want to make sure everyone feels real comfortable with the lab archives. So again, it's free for 2 weeks. It's $20 for the whole semester. So if you can go ahead and buy it, go ahead and do that. And then EOPS students, you will have to go on campus, and they know about already. They did this last semester. So the only one that we're doing is this one. This is all you have to do this week. You click it and it opens. This part, let's see if it opens, if it's working. Oh yeah, this is because students got confused last semester. They thought they could work in big groups. It's like, no. Everyone does this themselves, but you can obviously talk to each other. This is really good. This is also excellent as far as telling you about everything. And then what I really like, there's little videos. They're pretty short. They're less than 10 minutes. They're worth your while because I've been listening to you talk. I've been going in and out of the Zoom, the breakout rooms. And no offense, but you've forgotten your nomenclature. And that's going to haunt you the whole semester. So this week, take the time. These are very worthwhile to watch. And again, they're very short. This is what we're talking about. There's patterns. So you don't have to memorize everything because there's lots of patterns. This is very well done. Good examples. There's all your different charges. There's our aluminum +3, always zinc +2, always silver +1, always. These guys have changed. Look at the manganese. Ooh, look at the chromium. So this is, again, very good for you. It doesn't take you that long to read. Because when I'm grading this, I'm going to highlight all your mistakes. And I'm going to add those up. And then you're going to start losing points. So when you see this, it's, like I said, less than 10 minutes. Very, very well done little YouTube videos. Oh, look, there's the look, there's the thiocyanate. It was right there. And there's the cyanide. Yep. Most common ones. People get mad when I use oxalate, and I'm like, well, it was in your chemical nomenclature. And like, well, I didn't know it was oxalate. Well, but it was there. Yeah, this is all fair game. Yeah, the dichromat is kind of weird. These are common ones that we'll see. So you definitely want to take the time to look at them. So this is probably faster than your book, and some of you might not have your old book. And look how nicely this is explained. And they've got 9 examples so far. To the example, we got 10 examples. That's really, we got 11 examples. Nice. I figured out how to just say the word video. So this is one of those little short videos. So there's lots of examples here, which is really good for you. And it does seem long, but everything is going to be helpful. And that way you won't have to pull out your old book. And I'm happy with all the examples they have. It's really nice. Oh, acids, man, acids and bases. You got to really know those guys. Look, oh my goodness, look at 23 examples that helps you. There's the hydrates. Okay, so then this is what you're doing this week. And then remember, you click on this. When you have a question, you hover on the pencil, you click on the pencil, you type in your little answer. Which I cannot spell. And then save to page. When you come back, what you've got on there will be saved. Please make sure you're completely done and then submit. If you submit and you're not done, you can't open it up again. It's already submitted. I have to grade what you submitted. Okay, so questions about your chemical nomenclature this week? Any questions? No questions? Are you sure?
This is also due on Sunday, correct?
Yes. We're gonna, every week, whatever is in that week is due midnight at 11:59. So when you guys submit this, there's a timestamp that I see. So as long as I see a timestamp, of January 31st, 11:59 or earlier, then you get full credit. If it starts being late, then it's considered a late assignment, and technically late assignments don't get full credit. But what's really nice is if you go in here and you see, well, I can't do all of this today, but let me get started. Oh, I'm sorry, that was the extra one I did in case people accidentally deleted. Okay, so if you go in here, here we go. So you could go in here and say, I can't finish today, but let me just do what I can. Bold. And then whatever I can get done today, I'm going to save that. It will come back up when you're ready to go. So when you go to the save to page, whatever you've got saved, it will be there. Because see, I had done this before, and then when I brought it up, it was there already. So you can just do this in bits and pieces, but always hit your little, make sure you hit the little save to page. And then when you open it up again, oh, look, let me show you. Okay, so I'm going to do a change. Let me make a nice color. So I do a change, I save. When I bring it back up, it's there. So you don't have to do this all at the same sitting. You just do it, save it, and when you open it up, it's got whatever you've already done, which is really nice. Other questions about your assignment this week in the lab archives? Okay, I also wanted to make you aware of this. See this? Look at that. That's a whole book. And I looked at it. It's decent. Okay, this is what we're doing. So if you wanted to, you could go here and you've got some review. You could review your nomenclature here, although they did a really nice job in this assignment. But now, if you look at this, there's a whole chapter on kinetics. Whoa, this is what we did. You have an ebook here in your lab archives, so you're getting along with your lab archives. So we already did that. We defined reaction rate, blah, blah, blah. Oh, see, it's explaining what we did. This is a really good source for you that you're getting. And look at that. There's the minus. So you have another example from what we did. So this is a completely new example from what we did in our lecture notes, because I didn't have this when I was writing my lecture notes before you were born. This is a very good resource. I highly recommend it because this chapter is so new. You need to look at more examples, and it's explained really well. And I'm really trying to explain it well. Not that I'm, you know what I'm saying. Whoa, they give you a lot of data here. They explain what's happening. If you can have more problems to practice, that's good for you. And also to see what it means. Yeah, there's a lot of words. I know you don't like it. Oh, whoa. Okay. Yeah, see, this hopefully makes sense to you now when they're talking about the instantaneous rate at 12 hours. Yeah, it's looking a little, well, you understand it. They're talking about instantaneous rate. We talked about that. Oh, this is just to get you excited. And we did talk about catalyst. The catalyst is one way to speed up the rate. Oh, there's a bunch of urine strips. Oh, huh. Guess you can download it. Oh, look, we talked about this. So this helps explain the concept that we talked about. And I believe this is a different, yeah. See, this is a different example for you to look at. And so they're showing you what they did. So hopefully it makes sense because you need to see more examples. And here's your source of more examples. Okay, this is getting, okay, that's low. Yeah. I don't know if I want to look at that. Whoa. Okay, this is also what I really like. So one of the ways to be successful in this class is to practice more examples. Of course, you have to do your homework because you want to get all those homework points. But you also want to practice for the quizzes. So this is a whole different example. And then they're telling you what to do, write the equations that relate the rates of consumption of the reactants. And so this is a relative rates question like we were talking about. So you try it on your own. And then there you go. You check and make sure if you got it right. You really should use this book. I don't know why people didn't last semester. I don't know. Okay, so this looks like another one to practice. Oh, look at that. There's two right there. Another one for you to practice. Oh, another one. Excellent. This is how you're going to be good at this class, is to practice and then see the solutions. And it's all right here. It's already in your lab archives. So we've done that one. Oh, we did this one too. But I would definitely use it if I was you. And it's got all our chapters in here. Oh, we're doing, oh, look at, there's nuclear. So that is this, it says chemistry 2E, OpenStax. So that should be enough resources for you. You've got your guided notes, your lecture notes. You have another book here. Okay, do you guys have any questions? I know it's a lot for the first day, but it's at least we got through the first day. Yes, and we had like no technical glitches.
Do we have anything that needs completed before our next class?
No.
Okay.
I don't expect you to do anything before the next class. So all your assignments are due 11:59. Some students did like watching the kinetics videos before. And then they told me that when I was going over them, they just kind of sat back and listened for a second time. So it just depends on what kind of a student you are. So some students felt overwhelmed doing that. That's the flipped classroom. It really depends on you. The flipped classroom works really well for some students. Other students hate it. So you're welcome to watch the videos ahead of time, and then when I go over it, then it's like a second time. But I don't expect you to. There's just too many students working to help their families, and so I'm not going to make this a flipped classroom.
Thank you so much.
Oh, you're welcome. Any other questions? How did it go today?
Well, this review was a great birthday present. Have a nice day.
Is it your birthday?
Yeah, have a nice.
Oh, happy birthday, Monty. Oh, see, we're face to face. I could have made cupcakes or cookies. I at least could make cookies. My son would let me use his oven. I still don't have an oven. Oh, yeah. What was that thinking?
I'm allergic to everything that is fun.
What? Okay, where's the thingy? Aw, Matty, you had a birthday during the pandemic.
Oh, it's fine. This is how I usually spend it.
Oh, no. Matty, that's so sad. Well, yeah, because your birthday's during class, right? Okay, any other questions?
Did you take a run at the beginning because I joined a little late?
No, I did not. Because there's no one wanting to add, as far as I can tell. And I kind of looked and saw, I counted the names and I counted enough names. So I figured everyone eventually was here.
Oh, okay.
Any other questions? Other questions, comments, anything?
Thank
Keep them nails.
Oh, you're welcome. We've got 15 and a half weeks. Anything else? Okay, I will be here in the Zoom room. If you have questions, just pop back in this room. You go in the waiting room, I let you in. We made it through the first day. Excellent, I'm happy. You're free.
Thank you.
Thank you.
Have a nice day, Professor. Good luck.
Thank you.
Thank you. Have a good day.
That's it.